You're listening to For the Fighter in You.
Oh my goodness, what a treat we have in store for us today. One of those rare finds, an accomplished medical health researcher who can effectively translate complicated science to the layperson. In addition, this science that he is translating is decidedly exciting and promising. Dr. Dayan Goodenowe is a synthetic organic chemist. His PhD is in psychiatric medicine, looking at the biochemical mechanisms of psychiatric diseases and how the cellular systems of the brain interact with each other. In addition, he's also the founder, president, and CEO of Prodrome Sciences, and he's the author of Breaking Alzheimer's, a 15-year crusade to expose the cause and deliver the cure. This book goes into critical detail about the biomarkers of dementia and Alzheimer's disease and the science and clinical applications of plasmalogens for the therapeutic treatment of Alzheimer's disease. Dr. Goodenowe, welcome, welcome, welcome.
Thank you so much for having me. I'm really excited to talk with you here today.
Thank you first for dedicating yourself so tirelessly to this subject. It's life or death for so many of us. And you and I were speaking extensively before we started recording. We realized we're never going to get to the record button because we are just enjoying the conversation so much. So we're finally now recording. I guess we'll start from the beginning because I am guessing that plasmalogen is a new word for a lot of us. So maybe you could start off with telling us what the heck is a plasmalogen?
Sure. Well, and it's interesting. See, my background, like you mentioned, synthetic organic chemistry, neurochemistry, looking at biochemical mechanisms of psychiatric disease. And so back in the early 90s, mid 90s, the genomics revolution was in full swing. We were sequencing all the genes of the human body, but also of other species. And being a biochemist, looking at the small molecules in the human body, there wasn't any comparative capability where we can measure all the small molecules that make up our daily living. Like the human body takes in carbohydrates and proteins and fat and breathes in oxygen, burns it like your car into carbon dioxide and water. And so, we don't take sunlight to grow. We have to build everything that you see in front of you has been built from small molecules that we ingest. And that's the biochemistry of the human body. And so I invented a technology in late 90s called non-targeted metabolomic profiling using high field mass spectrometry, using like an ion cyclotron. And this allowed me to measure thousands and thousands of molecules. And we were using it for functional genomic research and a bunch of other things. And of course, my interest is in medicine and health. And so when we started applying this technology to human health, cancer, autism, Alzheimer's, multiple sclerosis, when we looked at Alzheimer's disease and people with different degrees of cognitive impairment, we discovered that there's a certain class of molecules are being decreased in the blood of people with cognitive impairment. And when I researched these molecules, isolated them, structurally elucidated them, they turned out to be these molecules called plasmalogens, which is a word that no one has heard of. And quite frankly, it's one I never heard of. And I'm an expert. This is what I do for a living, is biochemistry of the brain. And so I basically had to research what plasmalogens were myself. And they're a molecule that's part of your lipid membranes. And they're not like trace levels. It's not like a small amount. 20-30% of your entire brain lipid volume are plasmalogens. So we've known about plasmalogens for about 100 years. So it's not like we've never known about them. I just was never taught them in school, even though they're such a critical component of neurological membranes, not just in your brain, but your eye, your heart, kidney, lungs. Children that are born premature that have bronchial dysplasia, that's caused by plasmalogen deficiencies. Children that are born with mutations in their ability to make plasmalogens, they rarely live past a few years of life, have severe dwarfism, neurological deficits. So the critical component of plasmalogens are known for years and years and years. But this idea that they were decreasing later on in life, and this decrease was associated with reduced cognitive functioning, was something that I discovered with this blood work. And then we went on to do much more extensive analysis of mechanistically why, is this just a bystander at a car accident, or is this something actually putting spikes in the road causing the car accident? And it turns out these things are actually causing the cognitive decline. And it's part of the functionality of your neurons. And so there's a very large amount. The weird thing about them, though, is that they're so important that the body doesn't even rely on dietary consumption of it. The body makes all of their own plasmalogens. So you make all your plasmalogens. So it's kind of a double-edged sword. So one part, it's so important that the body cannot depend upon dietary supplies, but likewise, that becomes the Achilles heel of the plasmalogen system. And that as we get older, if we lose the functionality or we're unable to make as many plasmalogens as the body needs, we start getting depleted reserves. And the big areas that they reserve is in the brain, like the white matter tracts. And we'll talk about white matter, especially when I want to discuss today about concussions and concussion recovery and all that kind of stuff, because plasmalogens are really critical, involved in that white matter protective zone. But I know I'm getting a long story. So plasmalogens are critical biophysically for the release of neurotransmitters. So they're the switching part. And so that's why these plasmalogens are critically important. And I tell people the easiest way to think about neurology, and we'll talk about this in terms of concussions but also reduced cognitive functioning. People think of the brain, they think, oh, it's like a computer, but it's not really like a computer. It's more like a car wiring system, if you think about it. Like you have the wiring harness where you have a whole bunch of wires all bundled together that are going from the front of the car to the back of the car. And then you have where the wires end, you have switches, kind of like the light switch on your wall. So the wiring inside the walls is like a copper wire, has a wire on the inside, has an insulated sheath around it, and then it becomes bared at the switching part. So your neurons are the switching part, and those axons are the wiring. And so plasmalogens are what happens when you flip the switch. It's the omega-3 plasmalogens that allow that signal to go from one neuron to another neuron. And that's both in the brain, from neuron to neuron, but also the neuromuscular junction. So when you're trying to tell your fingers to move or your legs to move, that's a neurological connection. And that neurological connection requires sufficient plasmalogens in that switch, that synapse, they call it. And so that's kind of and then the other area of plasmalogens is that connective tissue that protects the axons so that the signal can go long distances and maintain its speed and strength. And when you lose that protective tissue, that myelin sheath, like when a mouse gets in your walls and starts chewing on the wires, all of a sudden the signal doesn't get from the power source to your light bulbs and the lights don't go on, or they flicker, or they don't work properly. And that's basically because your wiring gets short-circuited. And plasmalogens are molecules that protect those axons and allows that signal to go long distances. And so that's kind of where the plasmalogen story came in terms of Alzheimer's. And so as your body has an inability to make enough of them, you eventually start bleeding out your plasmalogens. It's basically a mathematical equation of your reserve capacity. And you start getting brain shrinkage, you get muscle wasting. These are things that are all associated with reduced plasmalogen levels. And so that's kind of so the next thing obviously says, you don't want to be in a situation saying, oh, you have low plasmalogens, sucks to be you, but you want to be able to fix that. And how do you get plasmalogens into the human body becomes a scientific issue. And so I invented and designed plasmalogen precursors. They're natural, they're biochemical intermediates that get converted into plasmalogens into the cells of your body. So you ingest them orally and they go into the brain cells, the neurons, but they also go into your other cells of your body and allows those cells to make the plasmalogens they need to function appropriately. And that's going to be a big issue when we start talking about concussion and what the biochemical mechanism of neural inflammation and concussions are and the long-term consequences of concussions. And so in Alzheimer's disease, what happens over time, we all have a reserve capacity. Like your body is built with excess capacity. And it's only until that excess capacity has reached the threshold that we start seeing symptoms. And so part of what I do is biochemical engineering of humans. We basically say, how do we get your savings accounts back up again? How do you get high levels, not just of plasmalogens? Plasmalogens are absolutely critical, and they're a big hammer for improvement. But there are other, your human body has other things in it as well that needs to get working properly. And so biochemical reserve capacity is a real critical thing that we focus on, trying to get to functionality. And this is where people talk about the difference between disease prevention and disease treatment versus longevity or vitality. Vitality is different than survival. And sometimes economic explanations are better than scientific ones. It's like money. Okay, technically, you only need enough money for food and shelter, okay, to survive. But that is a miserable existence. That is not an existence of vitality. That's an existence of bare survival. So technically, the human body just needs to make sure the lungs are working, heart's working, and you can keep yourself enough oxygen flowing to the brain, and you're fine. But vitality is measured in having excess capacity to do all the little things that you don't notice right away. It's like, you tell people, it's like school teachers. Okay, does the world need school teachers to survive? Well, technically, no, not for a short period of time. If for a short period of time, school teachers have to be hunters or farmers to survive, fine, we'll get by. But a prolonged absence of school teachers, society will end up having less vitality. We'll have less education. We'll have less smart kids. And so but you won't notice the difference. If we had to stop all school teachers tomorrow, it would probably take us several years before we'd actually notice a reduced vitality of our society due to lack of education. And so your body's making these choices all the time. Okay, and they're saying, okay, how do I choose to support the heart, or do I choose to support my skin or other minor functionalities of the human body? So understanding vitality is a very different concept versus understanding how do I get to the basic survival capabilities of the human body. And we don't have a lot of measurements for that, so all of our information about what are the recommended daily intakes of vitamins. Well, yeah, so I can say, hey, you need a certain amount of vitamin D so you don't get rickets. Well, no one gets rickets anymore. Or scurvy for vitamin C, so we have these, or pellagra. So we have these diseases of really severe deficiencies that we can prevent with very little amount of the appropriate vitamin supplements, nutritional, biochemical systems. But that's not vitality. That's base survival, biochemical survival. So when we start looking at enhanced function or even maintained function, like, you can't really get beyond full functionality, but you want to maintain that full functionality. So that's about understanding where we get these biochemical reserve capacities. And one of the biochemical reserves that you really need is plasmalogens. You just don't want to be, it's a 30-year difference in lifespan for people with high plasmalogens in their blood versus low plasmalogens. It's a big deal. Plasmalogens are a really scary thing. Like, you do not want to be low of plasmalogens, period.
So here's the couple analogies that come to my mind that maybe will help, certainly help me to clarify with you and hopefully some of the listeners. So on your metaphor of school teachers, what the visual that came into my mind while you're talking about, communities or societies who invest in education and versus those who don't. So what came to my mind was the country of Afghanistan. They're kind of reaping where they put their investments and where they don't put their investments, versus a country like Sweden or Norway, which are high investors in education and having the best school teachers, treating their school teachers like we treat entrepreneurs or captains of business. That's the Scandinavian countries, that's how they treat their teachers. And look how low their crime is. Look at if you measure their happiness quotient, right. That's how you measure their success. They're at the top of the food chain in the world, and Afghanistan's at the bottom. So that was kind of a helpful metaphor for me as you were explaining the investing in your teachers versus not having that reserve. Quick back up just so for visualization. I'm realizing I'm a visual person now because I'm trying to visualize everything you say. Is a plasmalogen actually is it physically the lipid, or is it physically a molecule inside the lipid?
It is the lipid.
Okay.
It's the same thing though. The lipid is a molecule.
Oh, gotcha. Okay.
So your body, here's a good point. So your body is compartmentalized. Okay. So how your body can do functions in one area versus another area is through compartmentalization. The same way we compartmentalize our house. And like, so you have things that you do in your kitchen, in your bathroom, in your bedroom, and you have walls that separate them. So you can do certain functions in certain areas without affecting functions in other areas. So the body has over 200 different cell types of the human body. Okay, you have your cells in your heart, your lungs, your kidney, your brain. So you have physical separation, long distances, and then you have close separation. Like I mentioned, the wiring of you have the axon, which is a neuron in the inside. Then you have the glial, which is the oligodendrocyte, the covering of the axon is another cell. So those are very close to each other. And how the body creates these compartments is using membranes. Okay, that's so membranes in the human body are biological walls. That's how the body separates, makes divisions. And those biological walls are made of molecules called phospholipids. And plasmalogens are one of those phospholipids. Okay, so plasmalogens are basically, like, you can think of it as a building material in the walls of your house. And if all of a sudden you don't have enough plasmalogens in your walls start shrinking. And all of a sudden your doors don't open and close properly. And the vents, okay, you get constriction, so you don't get enough airflow through the vents. So you can imagine, like, so it's a critical structural component of the actual human physiology. So it's a core component of all the biological membranes of the human body, and it has slightly different activities in different areas, but that's fundamentally how it is.
In the neurological space, doctor, and correct me if I'm wrong here, but it sounds like there could be applications here for some of the common threats like MS, Alzheimer's, schizophrenia, autism, Parkinson's, ALS, and just countless. It seems like there's become an epidemic of neurological disorders, and that maybe we could address why that's happening, and if raising the plasmalogens would address those issues.
They do in certain aspects. So autism is a big pet peeve of mine. It's dramatically accelerating. Like, we have data now from Scotland, 4.5% of boys are getting autism in Scotland. It's insane. Okay, this used to be a disease that you'd see 1 in 100,000, 1 in 300,000 kids would get autism. And it was a neurodevelopmental disorder when it was originally discussed or discovered. And what I mean by that, a neurodevelopmental, is that the child was actually born with autism. Now, they may have diagnosed it once the child failed to meet certain developmental milestones, but the child had it from birth. Okay, this reduced neurological function. Autism of today is not a neurodevelopmental disorder. Okay, children develop normally, and then they become autistic. It's a very different thing. So we have an environmental disease masquerading as an old neurodevelopmental disease. Okay, and there's many different aspects of, X-linked adrenoleukodystrophy and other types of male-focused diseases, because there's a gender bias. But the autism of today is a mitochondrial disease. And autism and multiple sclerosis are fundamentally the same disease. MS affects 3 times more women than boys, and autism affects about 3 times more boys than girls. And if you look at their levels of sex hormones in their pre-puberty, that about 25% of girls have, say, boy levels of beta estradiol, and about 25% of boys have girl levels. And that explains the gender bias fundamentally in autism. But the environmental inflammatory component, so we have a generalized increase in inflammatory environment. And if you have, say, people that were just on borderline, they have their mitochondrial function was borderline, they'd be fine. but then you increase the overall stress load, and then people that were borderline now become autistic. And so we've created this environmental stressor, and there could be there's not just one cause of autism. Could be 100 different causes of autism. Fundamentally, though, it's the same thing: oxidative, increased inflammatory stress, and that, with a mitochondrial weakness, creates an autoimmune disease in the body. And fundamentally, it's the same thing. Autism and MS are the same thing as concussions. Okay, one is being caused by a generalized inflammatory disease, and the other one is caused by an acute event that then creates a longer term inflammatory disease. So get to the point here is that the mitochondrial dysfunction stress prevents the cells from maintaining their oxidative balance. And one of the things that plasmalogens do is reduce oxidative stress, reduce peroxidative membranes, rebuilds the white matter in autism. So when we give plasmalogen precursors, we prevent demyelination. So plasmalogen precursors is very, very powerful at preventing loss of white matter. So yeah, so the answer, wow. So autism, so we have protocols going on right now where we take, so there's two types of plasmalogens. There's omega-3. People think about DHA from, say, your fish oils or for algae oils. Those are activating. They're synaptic activating for performance enhancement. We want that for Alzheimer's, for improved neuromuscular junction function, improved athletic performance. Like that's where the performance capacity of the plasmalogens come in. Omega-9, which is your oleic acid, that is your protective plasmalogen, and they'll go across the glial sheath. So autistic children, when they, like I have people working for me that are on the spectrum that their lives have been changed by taking the proton glia, the omega-9 plasmalogen. They get their focus back. We reduce neurological inflammation. So we're having pretty dramatic results in autistic children with the glia system because it's reducing neurological inflammation. And it's a kind of a mathematical equation. If you have an inability to maintain the membrane, the myelin sheath, then you're always underwater. They're always trying to catch up. They can't get ahead. And so when you can provide the precursor and they finally get ahead of the curve, the inflammation goes away. And that's what we'll talk about. I'll explain in a little while more about concussions and the physiology of concussions and what it actually means, and some of the advanced research that people are doing with more advanced MRI. But that's fundamentally with autism and MS. Those are mitochondrial diseases. And what happens is you get an inflammatory event, and the event doesn't stop, it spreads. And so inflammation is a naturally good thing. Your body needs inflammation because it's how you get rid of sick cells. But when the inflammatory response, whether it's your macrophages in your periphery or in the brain, it's your microglia, is the cells that float around and look for neurons and cells to piss them off, basically saying, are you oxidized? Is there some weakness? Okay, they're looking for weak cells, because when they find a weakened cell, they're going to attack that weakened cell, do a final kill, and then clean up the garbage, because you don't want a cell to die without the garbage men around to clean up the garbage, because the garbage inside the cell. Right, exactly. Senescent. So, but the point is, when those microglia attack a weakened cell, all the cells that are normal and healthy around that weakened cell are supposed to be able to be strong enough to withstand the inflammatory response. But if they are weakened, then all of a sudden the inflammation response itself causes those surrounding healthy cells to become unhealthy, and they then become further signals to the inflammation saying, oh, well, now you're sick, so I'm going to go after you now. Okay. And so it's like so when you look at a multiple sclerosis lesion, it starts small and it grows outward like a forest fire until it burns out of material. And so you want to be able, so by supporting the surrounding cells, you keep inflammation isolated, and then inflammation goes away, and then you can get the remyelination process to go. So that's when autism and MS is involved. So women with multiple sclerosis, okay, especially when they're younger, premenopausal women with MS, if they get pregnant, when they're in proestrus, most times their symptoms go away. They're always in a relapse during that time. And then the remitting phase. And so when they get to postmenopause, when their beta estradiol levels, that's when multiple sclerosis typically transitions into secondary progressives. So yeah, so it's a very, these are things that we can work on. So we can restore this biochemistry from the inside out. And rather than trying to suppress the inflammation, you want to pull the logs out of the fire so that there's no place to, like, you calm the fire from the inside out, rather than trying to take a hammer and or a big, drugs to douse it type of thing. So that's where the MS and autism, Parkinson's is a little different. It's a little cell mass called the substantia nigra. Parkinson's is a weird one because you get the insult 10, 15, 20 years before you see the symptoms quite often. Okay, so what'll happen is, maybe you're off on some fancy vacation and you have some bad meal in some strange little location around the world, and it knocks out 20% of your substantia nigra dopaminergic neurons. You don't even know it. You have no idea. You're fine. Okay, maybe you got sick one day, but then 20 years later, when you've had your natural brain, has been degenerating a little bit here and there, and all of a sudden, rather, you see these symptoms of Parkinson's coming in, but you don't know it didn't happen yesterday. It happened 20 years ago. And so that's where you get this accelerated, it's basically accelerated brain aging. So whenever you lose reserve capacity, you have accelerated your aging process because you've lost that reserve. And that's what concussions do. And that's why for athletes, a lot of athletes have a reduced aging vitality because they have lost reserve capacity. And so fast forward 10, 15 years, then all of a sudden they've lost that extra gas in the tank, if you will. And so they just run out of gas quicker because they've lost reserve. And so what we want to do is we want to restore that reserve capacity and rebuild that biochemically and just kind of start refilling those tanks up and then keeping them full for the rest of your life.
We're talking with Dr. Dayan Goodenowe. He is a synthetic organic chemist. His PhD is in psychiatric medicine, looking at the biochemical mechanisms of psychiatric disease and how the cellular systems of the brain interact with each other. He's also the president, CEO, and founder of Prodrome Sciences. He's the author of Breaking Alzheimer's, a 15-year crusade to expose the cause and deliver the cure. And he's talking about one of the most fascinating molecules, lipids, that I think perhaps I've ever heard of, and maybe you too now, just listening to him for this brief amount of time, plasmalogens. And this, I'm like, right now, my brain is blowing up with the potential for healing of diseases that were quote unquote, not unhealable. I mean, unhealable, and diseases that were a death sentence seem to be not as scary now all of a sudden. You had mentioned, Dr. Goodenowe, CTEs, which thank you very much for doing that, because that's a huge subject now, especially in my space, in the fight space. I also have a 13-year-old daughter and an 11-year-old boy, and they both play very active sports. My son is begging to play tackle football. It's not going to happen. He can play flag football till his legs fall off, but he's not playing tackle football. Maybe if you would be so kind as to tell us what CTEs are, and are there any applications for mitigating CTEs or preventing CTEs with plasmalogens?
Yeah, so when you talk about concussions, and whether they're severe or mild, and when people get the initial symptoms of dizziness, memory loss, severe ones like headaches, and then they eventually get a return to play designation, right? And they think, okay, my brain is healed. That's just actually not true. And the data is pretty clear that's not true. But I think people have to, let me kind of explain. I talked a little bit earlier about, the brain is not really a computer. It's more like a car wiring diagram where you have a wiring harness, and that's your white matter. So you have the two hemispheres of the brain that are connected by a white matter tract. And so you can think of the signaling Okay, like you have switches, like on the switch of your wall, and there's two wires that are connected and they go in different directions. You have the white matter of the brain. So if you think of your head of a beach ball, the outer surface has the largest surface area. And that's where all of your gray matter is. That's where all the connections, all the switches are occurring. And then in between, going in and connecting the gray matter zones is your white matter. And that is your axons. Those are the long wires. Okay, and that connective tissue is what gets damaged in a concussion. Now, when you can visualize like a wiring harness in a car, like you have a handful or a pipe here, and you have about 50 wires all tied up going in one little bundle, like a bundle of wires. So you have a bundle of wires, but each of those wires has its own coating around it. Protect the wire. Otherwise, if you didn't have the coating, the wires would short circuit. If you ever see a burnt up car or a short circuit car, if you see the melted wiring, all of a sudden everything doesn't work. Well, that melted wiring is the equivalent of a concussion or equivalent of a stroke. Okay, the wires melt, and all of a sudden, or the protective coating of the wirings melt, and so all of a sudden these wires can't transmit their signals, and they cross react. Okay, they short circuit each other. Now, so imagine that you have that pipe of wires, but now in your car you have like 50, 100 wires all in a bundle. Okay, the bundle of wires in your brain, there are 200 million wires. 200 million wires, each with a copper wire, each with a myelin sheath protecting it. Now, these are living cells, and they're all tucked together like this. And so the outside myelin sheath is, and then of course you see there'd be space between them because they're spherical, right? So they can't be completely packed. There's going to be some fluid slightly around each of those wires, no matter how tightly you pack them. So now what happens is that they're stuck together, and you get a head injury, you get a concussion. And what happens now is you get the shear stress. These wires move a little bit across each other. You get this little friction. And so the protective coating of one axon, which is next to the protective coating of another axon, it slips a little bit, okay? And that tears, and that creates a damage. And now the damage has to get recovered. And so the cells now have to rebuild that myelin tear, and that creates a huge inflammatory event. So you have brain inflammation. So while it's repairing that protective coating, it swells and it causes an inflammatory event. Now, your brain, unlike your muscles, like your brain isn't designed with the level of circulatory system that the rest of your body has for regenerative capabilities. And you have the broad brain barrier, which protects your brain from the rest of the environment. But like any situation, once you're inside the castle, you're kind of trapped inside the castle as well. So inside the brain doesn't have a lot, because of the blood-brain barrier protecting it from the outside world. It also forces the brain to fix all of its problems itself. Okay, it has to, whatever repair organ activity has to come from within the brain, not from within the periphery for the most part. And it's not designed to have that level of circulatory system. So when you get an inflammation event like a concussion, those cells right near it they're the ones that have to repair it. Okay, it's not, the repair is not coming from the rest of your body, it's coming from right there. And so there's a limited capacity of how much physical repair can occur. And one of the big things that tears is plasmalogens, because the white matter are the plasmalogens. So there's been really good new advanced magnetic resonant imaging of the brain called diffusion tensor imaging, DTIs. But that's what we used to measure for years and years and years on white matter integrity. But there's new advanced ones called NODI, which takes this white matter and breaks it into 3 components. So we can actually measure the water inside the neuron, inside the copper wire, and the water in the white matter sheath around it, and then also the water outside of that. So in a 3-dimensional, if I take a little plug of your brain, that's going to have 3 areas of water, and we can measure that water diffusivity. So when you get a concussion, what happens is, and your brain can't just swell and like it's fixed, like you have a fixed volume. So when that white matter swells, well, something has to happen on the inside. And so it basically squeezes. It's like taking your hand and taking a tube of toothpaste and just squeezing it. And so what you're doing now is you're constructing you're actually taking that neuron on the inside, because it can't just swell no place. It doesn't swell outwards, it swells inwards. And it squeezes that neuron. And in fact, what happens is the density of those neurons go down. So the number of axons from the 200 million, in a certain area, you get a reduced number of wiring. And so you have 200 million wires going back and forth. And so you might have 5 or 10 or 20 or 100 wires going to one location. So if you lose 5 or 10 of them, you probably wouldn't even notice a difference functionality, because it's not just one wire to one outcome. You'll have multiple wires going to one outcome. So you kind of get away with it. And so what happens in concussions, so you originally have the symptoms, and then you start recovering from the concussion. But most people don't actually recover from the concussion. They adapt to the concussion. And that's different than recovery. Okay, so what happens then is you adapt to the inflammation of the brain. So even when people get the return to play sign off, the level of white matter inflammation is almost unchanged from when they had the original concussion. And one of the worst things about concussions is that it can continue to get worse and worse and worse and worse with time. So when we do studies of brain occlusion, like brain stroke, we'll occlude the carotid artery for like 30 seconds or a minute, okay? Just for a very short period of time, we'll block blood flow and oxygenation to the brain, and then we'll release it. And that's going to create a focal lesion in the brain. But we actually don't measure the brain damage until 10 days. And at 10 days, you start seeing brain damage. And then 30 days later is when you actually see the lesion. And that lesion grows for months. Okay, for a 30-second brain occlusion. So what happens is you get an insult. And that insult creates this inflammation that I talked to you about with autism, for example. And you get underwater. And the body can't get above. And so that inflammation, the microglia that are in there doing the protective mechanism of trying to clean up the garbage from that weakened part, the rest of the cells have also been weakened, and it overwhelms the ability of the brain to restore its inflammatory state. And so we have, examples where, a friend of ours, his child got hit by a car on his bike, was in the hospital, like got proton glia, he was out in 2 days. So in terms of understanding the biochemistry, what those brain cells need to restore the myelination, the proton glia, like the omega-9 plasmalogen molecule, is what the white matter need to restore the myelin sheath. Then you also need to restore the mitochondrial function. So N-acetylcysteine, carnotine are the ones that are used to make sure the mitochondrial function. So fundamentally, and we'll eventually run the clinical trials on this thing, but biochemically, to prevent a concussion, and if I had a child playing hockey or football, they'd be taking glia before every game. So if you have that in advance, then your brain can restore that shear stress on demand. So when we give animals in animal studies of brain degeneration, so white matter degeneration, which is the glial degeneration, or gray matter, which is a neuronal degeneration, if we pre-treat them with plasmalogen precursors, we can't actually cause brain damage. The brain is actually able to maintain its functionality and its morphology in the presence of the insult. Okay, and it's just basically math. It's like this is not crazy, it's just mathematics. It's saying, okay, how much, if you have an injury and you have to restore the injury, it's like imagine your house is burning and you're on the inside and you have the ability to rebuild walls while the fire is going. Okay, and so you're building the wall as the fire is attacking you. And if you can build the walls faster than the fire can burn your house never burns down. Okay, but as soon as you can't rebuild at the rate that the damage is degenerating you, eventually the house burns down. Okay, and so, maybe that's burning is probably not the right example, but some sort of insult where if you're on the inside, and so by providing the right biochemistry on the inside of the neurons, or inside of these oligodendrocytes actually is the actual cell type, then you can maintain the myelin sheath in the presence of the damage. And so once the insult and once the pressure disappears, then it has created no damage. Right?
Oh my God. I mean, like the repercussions for this are shocking. Like what you're talking about, this science should be being screamed from the rooftops.
Right. But we look at the world, like the problem is that we look at the human body like a bunch of pipes and gaskets, and it's a living organism. Like our pipes are not just metal, they're alive. Okay, and they're being maintained. And so the physical structure of the human body is a living physical structure, not a static physical structure. And so maintaining the functionality of those living structures is really maintaining that biochemistry of those structures. And and the body is quite resilient, right? We're designed to get nutrients from our food supply. The nutrient quality of our food supply has decreased over the years. I come from a farming background, so for the last 100 years, we've been developing crops to get higher and higher yields. So instead of corn or wheat yielding 20, 50 bushels an acre, it's now doing 100, 200 bushels an acre. Well, if the same plot of land is giving you 5 times more product, mathematically, it has to have less nutrients in it. And so so we have this happening in our society. Nutrient quality, the human body was designed, or not designed, it adapted to a certain ecosystem, and we've changed that ecosystem. So we no longer live in the ecosystem that we were adapted to. And so that's where supplementation, or strategically supplementing the right molecules in the right proportions, are basically turn the body into a brewery, right? You want to have sweet tasting wine, the bottom line. So you have to feed the body the right nutrient stuff. And then as we go to one step further, how do we maintain these optimal reserve capacities? So and you can go down the list. So amyloid, we talked about amyloid deposition of the brain in Alzheimer's. I write about that. It's related to membrane structure and function, cholesterol transport regulation. Tau formation of neurofibular tangles is methyltransferase system. Your B vitamins like your B12 and B6 and folate. So these are things that we have a lot of knowledge. Like this is well studied, extensively studied for decades. So these biochemical mechanisms and this knowledge base is not foreign. It's the ability to implement it is our challenge. Right? When I talk about N-acetylcysteine and carnotine, like these things are cheap as dirt. You can buy them by the bucket. And so
it sounds to me like the mechanisms that you're talking about, the destructive mechanisms, the perfect storm, if you will, of the autophagy kind of eating up the weaker cells, which creates weaker cells, which makes them eat up more, which creates, it's like that perfect storm. It sounded very similar, the mechanism in MS and CTE. First off, is it similar? And secondly, if that's the case, is it similar with all tissue destruction? Does this go across specialties? Because we have such a separation in our Western medicinal culture of topics where you talk to a neurologist, they talk to a cardiologist, and they don't seem to be talking to each other.
Well, they look at things in isolation. Okay, and it's hard. Like you become an expert in one field, and it's enough just to stay up on cardiac function, neurological function. So the answer is yes, these things go across multiple fields. The autoimmune, okay, when we talk about autoimmune, we have a lot of this allergies and a lot of kids with autoimmune disease nowadays that we never used to see. Autoimmune is nothing more than perpetual inflammation. It's where the inflammation resolving capacity of the body doesn't go away. Diabetes is basically the same thing. So I tell people, if you think about just basic functionality, forget about whether you're talking about the heart or the lung or brain. There's two aspects of function. One is performance. And performance is all about neurological connectivity. In the movement of our muscles, movement of our heart, movement of our lungs. Like we have to signal neurologically. And that signal has to be strong and clean. Inflammation disrupts that. And inflammation is like tuning your radio station, but having the radio station slightly out of tune. And so it's staticky, like you've got a static radio station. And so if you keep the volume down low, you can still kind of hear the music behind the static. But if you start cranking the volume up, all you hear is static. And so before you improve the functionality of the system, you have to tune it. And so, but once you get the radio station properly in tune, you can crank that volume up as high as you want to and blast the walls out. But you can't, and so inflammation is that static. And so if you can't get performance enhancement unless you've been able to maintain that core inflammatory structure, inflammatory resolving, then you can pump the volume up. And so all these things, these progressive loss, long-term chronic inflammatory disease states, mechanistically they have a very similar thing. And this is where it gets they think, well, how can it be that simple? But it's not that it's that simple. It's that disease is complex. Health is not complex. Health is unifying. Your health, my health, our health is the same. And we actually know what health is. So as more and more people reach health state, they become more and more alike. So the healthier we become, the more alike we become. It's disease that gets the separation. So if it's a pancreatic cancer disease or a colon cancer, ovarian cancer, so I can have thousands and thousands of deviations from health. And that creates a very wide, diverse, complex milieu of adverse health. But health is fundamentally the same for all of us. So function is a unifying factor. How you deviate from function can be 1,000 different ways based upon our genetic predispositions and a bunch of other issues in our life. Okay, but so the same stress, you might get exposed to the same stress, and I might get exposed to exactly the same stress, and I might get Alzheimer's, and you might get Parkinson's. So the stress was the same, but our biochemical and genetic diversity had slight differences how we reacted to it. But our health is the same. So so when people start studying disease, it's like a complex, word puzzle. It gets farther and farther away you get from health, the more and more complex everything gets. And so you can start talking about all these, the minutia of every given disease, and I can sequence a given cancer, tumor, and so on and so forth, which is all true. Like, so once you have to deal with the disease once you have it, but dealing with the disease and dealing with health are two entirely different. The absence of disease is not health. Yeah. So, and then when you start thinking through that stuff, so if you're healthy, disease doesn't actually happen. So see, people think disease is some sort of protagonist lurking in the shadows, ready to attack you, and it's an active process. Disease is not an active process. Disease is a passive process. Disease can only manifest itself in the absence of health. Disease, you have an absence of health where disease can come into it. Disease does not take your health away. Your health goes away, and then disease comes into the void created from the absence of health. And so we give disease way too much power. And so we think that if we just fight the disease, we're going to get miraculous health. But that's just not how it works.
I had this, you keep painting these wonderful visuals for me. I had a sports metaphor came into my mind, and another visual came into my mind when you were talking about terrain. So tell me if I'm accurate with this visual depiction that materialized in my mind. I thought of terrain. I thought of a kind of a landscape, if you will, of mountains. And the mountains were underneath an ocean. So the mountains, the peaks and the valleys, let's call them genetic predisposition or genetic expression or non-expression, the mountaintops. As long as I keep my ocean above those mountain peaks, the ocean being the plasmalogens, as long as I keep the ocean above those peaks, who gives a crap which mountain is lower or higher? Why would I be worried about an ApoE4, which is terrifying to me, by the way, to not lie to you? It's terrifying to me. I don't even want to know if I have an ApoE4. But if I'm hearing you correctly, as long as my ocean top is above my ApoE mountain peak, who cares?
You know what? That is an awesome analogy. I am going to steal that. I'm going to use that one because that is perfect. That is perfect because and so essentially all of us have a different mountain range under the water. Okay, your mountain range and my mountain range are different, and so when the water level goes down, a different set of peaks appears in your ocean versus my ocean, and the difference in the peak of the mountains under the ocean, that's our genetic predispositions to disease. Okay, but none of them get revealed, none of them get exposed until the ocean level goes down. That's perfect. That's a really good way of looking at genetic predispositions because they don't actually appear until the reserve capacity gets below a threshold.
My work here is done.
This has been wonderful. I'm going to totally steal that from you. And,
I don't know. It just came into my head. And then the other kind of, you and I both like sports. The other thing that kind of popped into my head was Tom Brady, right? If I've got Tom Brady, and you and I talked a little bit about this before we started taping. If I have Tom Brady on the field, I'm not too concerned that maybe my sports rehab guy really did a shitty job on wrapping my last defensive end's knees, right? Because I'm not even like that. That's not even where I'm not focused on. I have a really bad bench when it comes to my athletic trainers. I'm on the Bucks. I've got Brady on the field. He's throwing strikes. We're killing it. It's not even. I don't even have to think about that.
That's true, and that's when you start talking about function versus biomarkers. Okay, and so the function here is: are you still making the same percentage of pass plays? Okay, is that still occurring? And if that's happening, then your offensive line is functioning at its normal capacity. Now, if all of a sudden, so if I do biomarkers and I compare, 20 different teams, and I say, oh, look at this, there's knee injuries or whatever it is on my, offensive line. I can correlate that, okay, with large enough number set to show that it's a biomarker of bad passing percentages, but it's not the reality. So that's what we do with biomarkers a lot. We get obsessed with the biomarker and not understand the function that the biomarker is there to measure. So so functionality is the end all. Like you have to maintain function. So yes, exactly right. So you can compensate. You can compensate for a defensive line with the right.
I should have gone with like fighter analogy. It probably would have been a little bit easier for both of us. Because then you have just one guy in the cage. You don't have to start thinking of defensive ends and personal trainers and all that. So this goes across tissue. How about with some of the other diseases that aren't necessarily neurological in nature, like cancer and heart disease? Is there functionality for plasmalogens in those spaces?
In a different way, but killers? So it's plasmalogens are really this kind of it's a bad penny that keeps on showing up when it's low. So virtually all cancers have low plasmalogens, and cancer is a disease of cholesterol regulation for the most part. So HDL regulation and transport, and then intracellularly, so you talk about intermittent fasting. So fundamentally, a cancer cell is a cell that cannot maintain a fasting state. And so he was, oh, cancer cells like sugar and they live on, glycolysis in the sugar system. That's actually not entirely true. Like it is, but it's not for the reason. Like cancer cells, they don't live on sugar because they want to. They live on sugars because if they don't, they'll die. And it's a different situation. So cancer cells have an inability to use fat properly for energy. And so they commandeer, I'm getting into the weeds here. So so plasmalogen defects are critical for creating a cancer risk profile. We talk about, a good example is a BRCA genotype. So BRCA for ovarian cancer and breast cancer. So the BRCA protein is a protein that elongates your fasting state. So your body has two gears that it runs on every day. It runs in a fed gear and a fasting gear, and it should switch cleanly from one to the next. So when you eat a meal, you have lots of energy, and your digestive tract, your gut is sending all this nutrient into your blood system. And the first thing it hits is your liver, which is your main energy processing system of the human body. And the liver says, wow, I got all this energy coming in. I can't possibly use all this energy at once. I better store some of this for later. And so what it does is it takes all this energy and it turns it into triglycerides, which is your long-term storage. Good old fat, just like your olive oil in your cupboard. Okay, it makes it. And so when you get your triglyceride blood test, that's not triglycerides from your food. That's triglycerides from your liver. Like your liver is actually physically making triglycerides, the oil, the fat. And then it's saying, okay, I'm going to store that for later. So it's going to take my food supply. I'm in the fed state right now. So I'm going to make triglycerides and I'm going to ship them to my fat cells for later. And while you're in that fed state, your body is catabolic, or it is consuming energy. It's like your cell phone is off the charger. You're running it down during the day. And then at some point in time, over time, you run out of that short-term energy, your fed state. You run out of that glucose, sugar energy. And your body says, okay, now I'm starving. So I need to switch from sugar, glycolysis, to fats or lipids, which is the best energy source of the human body. It's the cleanest energy. Good old saturated fat, palm oil, is the cleanest energy of the human body. So what happens then, all of a sudden, your body switches from the fed state to the fasting state. And it sends in your muscle, your fat tissue now becomes your stomach. And you digest your triglycerides from your adipose tissue and sends it in your blood supply to your liver. And your liver takes that and uses it for energy. Your mitochondrial beta oxidation, peroxisomal beta oxidation. That's how it's supposed to work. And that's when you build things. So exercise is a good part for exercise people. Okay. So I always tell people, look, exercise is bad for you. Recovering from exercise is good for you. Okay. So if you don't have the appropriate recovery time, you're not going to get the benefit from your exercise. So we get too many people that over-exercising. If a little bit is good, more is better. And that's just not true. So when you're exercising, you're ripping your muscles, you're ripping your connective tissue, you're creating a controlled stress environment. Then you got to stop. And your body says, oh my God, what did this guy do to me? So I got to fix all this stuff. And so it starts fixing all this stuff and say, I'm going to get prepared for next time he does this dumb stuff to me. So next time he does this, I'm going to be prepared. So your body adapts to the stress that you're giving it. And then you create a reserve capacity. So cardiovascular wise, if you're running, you end up saying, because when you're doing cardiovascular energy, you use more oxygen and you use more, like your circulatory oxygen energy utilization is up. So your body says, hey, I need more mitochondria. So you get your mitochondrial capacity increases with cardiovascular training. Your resistance training does a different situation altogether. It's short energy burst capabilities. And so when you weight train, your body says, wow, I've got to rebuild that muscle capacity and muscle memory for that activity. And that's a different anabolic activity. And that occurs at nighttime. That occurs in your fasting state. When you're in the fed state, when you're during the day in your fed state, your body is just surviving, it's hunting, it's getting stuff done, okay? And then it's when you're in your fasting state that your body recovers. Okay, so in cancer, the cancer doesn't switch to fasting very well, or it doesn't stay. It's like having a car that has worn out gears. It just can't stay in the fasting gear. It pops out of gear all the time. And so the BRCA genotype, so the BRCA protein, what it does is it maintains the fasting state. So when you switch to the fasting state, your body is using fatty acid energy. And that's when you build your membranes. That's when you make your plasmalogens. That's when you make your cholesterol. That's when you make your steroid hormones. All that stuff gets done in your fasting state. This is why intermittent fasting is very, very valuable for people. And sometimes with the keto in moderation is good because it creates this artificial fasting state. So cancer, when you're if you can't go into the fasting state, what it does is it commandeers your mitochondria. I'll get into the weeds here, but BRCA genotype, it keeps on switching the cell out of the fasting state. So it stays in the fed state. And so then it needs sugar to survive because it can't process fatty acids properly, which is what you mentioned, what you process. So since it's starving to death because it can't process the fatty acids that are coming in, it starts sucking glucose in. And so, and it adapts and trains itself to become a glucose or sugar dependent cell structure. And over a period of time, it becomes strengthened in that it trains itself to be a sugar loving cell. So plasmalogens, low plasmalogens are a biomarker of cancer, because if people have low plasmalogens, it means this fasting capability is screwed up in them. And then also it has a cell perpetuating problem because then your cholesterol regulation gets all messed up. So HDL, phosphatidylcholine, these are really, I've got a whole section on that regarding cancer therapy. So plasmalogens are something that are ubiquitously low. Virtually every person with cancer usually has low plasmalogens. And so restoration of that. So,
and you talked
sorry, it's a long
earlier-
story about cancer. It's cancer is a big story to talk about. I'm sorry about that.
No.
That's deep.
And I know it's a complicated disease. But I'm wondering, you had spoken about the precursors and how, raising of the plasmalogens is protective in these other diseases. Is the raising of plasmalogens, given the fact that cancer almost ubiquitously demonstrates as low plasmalogen levels?
Yeah, and it's a cholesterol regulation issue. So just to cut to the chase. So people, cancer concerns, pancreatic cancer specifically, is lecithin, good old-fashioned phosphatidylcholine. It's a big problem in our society. Choline deficiencies are a huge problem, especially with strict vegetarians. They're not getting enough choline in their diet. And not just straight choline, phosphatidylcholine, because that drives your reverse cholesterol transport system. So everyone talks about good HDL, good cholesterol, bad cholesterol, right? Which I don't agree with. They're both good cholesterols, but HDL is people call your good cholesterol. And that's true. You want high HDL levels, and high HDL levels prevents cancer. If people with low HDL is another major association with cancer, all causes of cancer. How you maintain your HDL system is good old-fashioned lecithin, phosphatidylcholine, because that's what drives your cholesterol regulation and reverse cholesterol transport. The other thing that all cancers have is cholesterol regulation problems, and that's part of this commandeering system that it does. It turns mitochondria into a anabolic system, and that's another whole big conversation. But
it sounds like there's so many rabbit holes that you could.
Well, it's basic stuff. It's actually, each of these systems are relatively straightforward. It's the human body at the very core level for all your viewers is the human body is a hybrid electric car. That's how the human body runs. We take in hydrocarbons, whether it's carbohydrates, fats, whatever, and we burn that hydrocarbon into carbon dioxide and water. And we use the energy from that burning process, just like your car engine, we use that energy to charge a battery. And the battery we charge is in the mitochondria. It's called the electron transport chain. And it's physically a battery. It's used protons, just like lead battery in your car. You have a battery in every single cell of your body. And you charge that battery with hydrocarbons. And then that battery runs your energy pump, which is called the ATP pump. And that's how the body converts chemical energy into biochemical energy, just like your car does. But so you charge a battery and you run ATP. And the cell that does that, or the organelle that does it, is called your mitochondria. And your mitochondria is supposed to be a pure nuclear reactor, pure energy. It's supposed to carbon's supposed to come in, oxygen comes in from your blood supply, and carbon dioxide and water come out, and energy. It's supposed to be just a pure energy generating system. So that's your catabolic system. Now your anabolic system are organelle called your peroxisome. That's what makes plasmalogens, makes building material for your cholesterol and your steroids, your hormones, and all that stuff. And that's where your anabolic system is supposed to happen. Cancer commandeers your mitochondria, and it converts your mitochondria from a pure catabolic organelle into an anabolic organelle. And it messes up all.
It's a fermenter versus an aerobic.
Correct. Correct. And so all of a sudden now your mitochondria start pumping out citrate. You see, look away, it makes your cholesterol regulation gets all screwed up. Your peroxisomes get suppressed, your good stuff, okay, because you need that for membranes and blah, blah, blah. And so you got a whole commandeering, like your whole, it just kind of steals and switches your whole biochemistry of your cell to a different purpose. And it commandeers it for its own selfish cellular activity. And that's how cancer works. So what you want to do is to prevent that, you need plasmalogens in your membranes because it helps. And your HDL system is important to clear the cholesterol membrane structure out. And so, but that's the fundamental aspect of it. Those two, so the body is like, that's how your body's supposed to work. So in your fasting state at nighttime, you're rebuilding. Your peroxisomes are active. In the daytime, your mitochondria are active. They're both active all time, but you want to build things during your recovery phase, and you want to consume things during your fed state. So
would it be safe or would it be accurate in any way, doctor, to call plasmalogens in some ways an antioxidant?
Okay, yes. So it is. It's
I feel bad because I keep sending you down these. I feel bad.
Okay, so
I'm trying to understand it.
There's really four main functions of plasmalogens. We talked about two of them. Okay, one is a neuronal synapse, the switching part. Plasmalogens are required for neurotransmitter release in the synapse because your switches are all biological. That's one part. That's the performance plasmalogen part. The second part is the omega-9 plasmalogens are part of the myelin sheath, the protective coating of your axons. Okay, it's a major area. The third part is the cholesterol regulation, HDL transport. So cholesterol esterification and transport are under plasmalogen control by an enzyme called ACAT, acyl cholesterol transferase. And then, but the fourth purpose, and so when people take plasmalogens, their C-reactive proteins go down and their malondialdehyde levels go down, oxidative stress markers go down. The fourth part is actually antioxidant. And so they have, what makes a plasmalogen is this very strange bond called a vinyl ether bond, which sounds exotic. And it is actually, it's the last step in the manufacture, but it's like a fuse. And it's designed specifically to neutralize peroxide and oxidative stress biomarkers. So it's your body's natural fuse box. And so and since that vinyl ether bond is physically located at the outer end of the membrane, like I was telling you about the walls. And so when cells get oxidatively stressed, the plasmalogen gets broken down first. And so it's designed to be sacrificed because your body can only make a lot of it. Like you have a lot of plasmalogens in your body. So your body makes a lot of it over time. So it's designed to say, hey, I'm going to throw this out there as a sacrificial molecule, and it'll neutralize oxidative stress biomarker, hydrogen peroxide, free radicals. And since it's in the actual biological membrane, it's your most important lipid antioxidant in the body. And that's its primary anti-inflammatory activity. Okay, so membrane oxidation is what attracts your immune cells to sick cells, and plasmalogens neutralize that. So yes, so that's why it has a huge antioxidant capacity. So those are the four main functions of plasmalogens.
Beautiful. And I think now is a good time to shift gears into protocols and things that people can do. And also just if people who are listening to this are like me in any way, I'm going to listen to this show myself. I'll probably listen to it 5 or 6 times myself, because it takes me that many times to ingest and to try to visualize what you're saying and to try to come up with those metaphors so that I like to have a grasp of why it's important to do. But there's also the other side to me. I don't have to understand it 100% to know that if I do X, Y, Z, it's going to help me. And for a lot of people, if that's what's going through your brain right now, don't feel badly, because that's what's going through my brain as well. Like, now I'm kind of at the stage now is, all right, doctor, just tell me what to do. So let me ask you a couple of really specific questions in that regard. If someone suspects that they're having neurological or cognitive issues, and they want to heal not just their brain, but at the same time, if they can heal their heart, if they can get better eyesight, because this goes cross tissue, any issues you may be having that are inflammatory in nature, it sounds like there's applications here for plasmalogens. What would be the best way for the people at home to increase the level of plasmalogens in? I get it that it's an endogenous play, that it's the body generating itself, but can we do something externally? Can we ingest something that helps that process along?
Yeah. So the plasmalogen precursors. So I have designed 2 types of plasmalogen precursors. One is omega-3 for performance, and it's called prodrome neuro. And one is omega-9 for protection, and it's called prodrome glia. So most of us, as we get older, like for me, I take 2 mils of prodrome neuro every morning. And then that restores your plasmalogen levels. At nighttime, I take the glia for membrane for building. Glia is also really valuable for sleep improvement. Protocol wise, for performance. So most people over 50, it's the neuro is the #1 priority, because as we get older, it's our peroxisomal function that declines most predominantly. Younger people that have issues, the prodrome glia is for younger people. So right to the brass tacks of things, in the elderly population, which is all of us, over, I wouldn't say elderly, but want to maintain long-term functionality, there's a couple core systems that you want to have operating properly. One is your membrane structure. This is this compartmentalization that I told you about. And the big issue for that is your lecithin, your phosphatidylcholine, and your plasmalogens. And this is going to be interesting for your viewers in the athletic world, but creatine is another big issue that we don't take enough of. Your body makes a lot of creatine. Muscle, weightlifters, you think about it for muscle mass, but it's actually for neurological health as well. And it restores your membrane, your methyltransferase system. So I look at #1 is membrane structure and function. So plasmalogens are critical for that. Plasmalogens, and make sure you have enough phosphatidylcholine in your diet. Okay, and creatine. Those are the 3 things that I recommend. Very simple, straightforward to maintain membrane integrity. Then the second area is your mitochondrial function. We talked about N-acetylcysteine and carnotine. And CoQ10. Those are the 3 big ones for mitochondrial function. And then this methyltransferase system, so you can identify these basic biochemical systems, protocols. The B vitamins, so B12, folate, B6 for neurological function. Those are important for prevention of neurofibrillary tangles in the brain. And then after that, you get into the other basic energy utilization supplements, your regular B vitamins, like your thiamine and riboflavin. And so those are the things that you want to have. And so I've written these things out in great detail, but that's the fundamental thing. But in terms of brass tacks, optimal neurological muscular performance from an athlete perspective, the prodrome neuro in combination with the N-acetylcysteine, carnotine for mitochondrial phosphatidylcholine, you're going to notice muscle improvement quite dramatically, muscle memory improvement, recovery from exercise quite dramatically. I'm just kind of a weekend athlete myself over the years, but I've always been, it's made a dramatic improvement in me. It's just weird stuff. I've been an athlete all my life, but I go off the wagon, I stop working out for long periods of time, travel and business and all that kind of stuff happen. And I know what it feels like to get back into shape and how it's going to be painful. I'm going to have all this. That didn't happen this time. Okay. And the muscle memory is weird. It's the strength. It's the recovery time. You work out to failure, right? And you normally think your next set of reps are going to be significantly less than your reps to failure, but I can do as many reps the second time as I did the first time after a rest period. It's very strange, okay? And the muscle pain's gone. So these are real practical things. My vision is back to when I was, in my early 20s. And so these are things that have physiologically happened to me personally in that functionality perspective. And so that's kind of where you want, in terms of plasmalogen restoration technology, in addition to other good nutritional capabilities that you want to do, but it definitely puts you over the edge, and you notice differences dramatically.
I am going to be a guinea pig for this because I am the before. Okay. I've got the junkie vision. I used to have 20/10. When I was in the military, I had an Air Force colonel who was a doctor, and he was giving me my visual test. He actually had me go one room away from the chart, and I read all the way to the bottom. He said, you could be a pilot. You could be a fighter pilot with your vision. So I went from 20/10 in each eye to junk now. And I know what it is. It's oxidation. I'm in my 60s. So that alone is just for anybody with readers or who can't see people far away. It's just like, I am so going to do this. But what I want to do is get any tests that I can that show visual proof, so that I can have any kind of medical tests that show where my eyes are, where my heart is, what my brain function is, whether it's PET scans from my brain. Maybe you can let us know all the tests we should take for anyone out there who loves to do before and afters, and wants to try this, because I'm pretty sure if anyone's 1/10 as excited as I am about this and the potential of this, they're going to want to get this and try it right away. What types of tests should I do so that I can actually directly measure my improvement on the plasmalogens?
So biochemically, we do advanced biochemical testing of plasmalogen levels, but also your phosphatidylcholine's, a whole bunch of other things. The test is called the prodrome scan, and it takes into account a number of things. It looks at your cholesterol regulation, looks at peroxisomal function, looks at your homocysteine and methyltransferase system, fasting triglycerides, all the stuff that your basic engine should be working under. Okay, so there's a kind of a triage approach. Like, you want to, there's core functionality biochemically that you want to have in its optimal space, period. Okay, and we measure that, well studied. And it's good to find out if there's any lurking problem that you had no knowledge was there, like choline deficiency. Some people they think they have a great diet, and all of a sudden it's not where it's supposed to be. So those are things you want to fix, that basic biochemistry of your body first, and that's easy to fix. Okay, you just need to measure it and then fix it. On the functionality side, most people they're doing their own things. Like, we notice people say nighttime vision, sleep improvement is a big deal. The physiological stuff, you want to look at heart rate variability, you want to look at blood pressure, you can look at peripheral nerve conductivity. The question is where you're going to get that kind of stuff performed. People that want to do it at home, mostly you're going to find it your own self. Like, it'd be subtle things that you'll notice. And that's what vitality is all about. Like, there's big things that you want to get better, but sometimes it's the little things. It's like getting better at trivia or remembering, rock bands from the 70s. It's this dumb stuff that you'll start saying, I'm remembering things now that I didn't. I'm connecting dots again. that weren't being connected before. And those are people say, and energy levels. You find your energy and just aware. People, the best way to think of it, when you take the neuro, you feel like your brain does this, like it kind of opens your brain like this. And when people take the glia, it does the opposite. It kind of narrows it. Like, so people that have attention deficit disorder, they describe the glia as like putting reading glasses on the brain. They can focus now. They can read full sentences without their brain wandering, and getting that focus back is the kind of how they explain it to me. That hasn't been my issue. My issue has been, well, really, I didn't think I had an issue, to be honest with you. So I took it because, my dad's in his 80s and I have him functioning like he's in his 60s. And
Wow.
so these are things that, he's my test subject.
He's your guinea pig.
My forward-looking kind of project. But yeah, that's I think you want to look at your own personal life. What are the things that are important to you? Muscle weakness, muscle pain. Those are things that you want to, exercise recovery rates, just basic strength training. You'll notice those things in your personal life. So I think that's kind of where people deal with it. And then depending on the inflammatory state. So people that have diabetes or they have other neural inflammatory issues, you should look into the glia for reducing inflammation. And so there's a combination of both. The ideal combination is the glia is the neuro in the morning for the day, and then the glia at night. Since it's a precursor, you're not taking the final plasmalogen, so it has a time curve. And so the plasmalogens and it's designed to be taken on an empty stomach even. So you're going to notice the effect fairly quickly, and then it lasts. And I still feel it every day. It's like an awareness. People take it before they go to board meetings and stuff like that. It just kind of turns their brain on, and then it lasts. And then I do intermittent fasting, like you recommend as well. My first meal is usually around 2-3 in the afternoon. So I don't have breakfast, and that's my main meal of the day is in the middle of the afternoon. And so I have my neuro and my other list of supplements that I take, my B vitamins, I have a long list of supplements that I take every day. And then, and that's all available for people on, we'll go through that. But, and then I have my main meal, and then I take some glia at night. It really strengthens the sleep.
What does your main meal consist of? I know you'd said, okay, you like the intermittent fasting. That, by the way, was a huge game changer for me. That was my first big result I've ever got in my biohacking, was all body aches going away, including, a 10-year run of sciatica gone instantly with the intermittent fasting. So there are certain things, like you say, that you just do them and you're like, oh, okay, I will never not do this now, knowing what it's like on and off it. Do you have any of the diet protocols out there that you think work very synergistically with the plasmalogens, like perhaps a low carb or a no carb, or where do you stand on that?
I take a balanced diet approach. If you're doing intermittent fasting, okay, then have a good meal, have a balanced meal. Like, I like my protein, like meat, vegetables, a variety of things. And I eat my desserts at lunchtime if I want some sugar. It doesn't bother me. So during your main meal, you don't want to have sugar all by itself. But if it's in your main meal and it's during your meal of the day, the intermittent fasting is fine. It's the fasting part that's the most important. And caloric restriction is your primary mechanism to get into the fasting state, which is time. So I'm a balanced eater type of person. And also I like my food too. So it's like whatever I eat during the day so I kind of just make sure I have a balanced meal of good protein, vegetables, and if I want to have a little dessert, I'll have a little dessert with my main meal. The biggest thing is at nighttime, I'll have just a protein snack if I have to have one, but typically I don't eat at all until the next day.
So you're like a one meal a day guy?
Yeah, that's my favorite. That's my best performance.
That's your protocol. Yeah. Hey, you mentioned too, how the plasmalogens, if you're building the walls faster than the fires are burning down the house, we're keeping that ocean level above the mountain peaks. It sounds like it's a tissue builder in a way. Would there be any kind of efficacy for people who have leaky gut?
I don't know if that for sure. The glia appears to be more anti-inflammatory and more calming. And leaky gut, like the glia, certain probiotics. I recommend often a product by Gerber, and it's usually in the baby section at the drugstore. It's called Gerber Soothe, Soothe. And it's a liquid formulation of Lactobacillus reuteri. And that's a very powerful probiotic. It's very gentle. First of all, it's for babies, and it's one of the earliest bacteria that the mother gives to a child after birth, and so that has pretty powerful liver function, but anti-inflammatory, gut improvement capabilities. And that, in combination with the glia, which is the omega-9 plasmalogen, is quite gut restorative in, say, inflammatory bowel disease and stuff like that. And so leaky gut is a good challenge. It's trying to get the right microbiota balance in your gut, and that that Lactobacillus reuteri is a good place to start. There's lots of different supplements out there for probiotics, and it's always a challenge. You just never know quality control, this and that, and so on. So, but that one's been around a long time, and if anyone goes on Amazon and looks at the reviews, it's pretty amazing hearing what mothers have experienced with their children on it. So it's a pretty good
Gerber Soothe.
safe bet.
I'm going to get some.
Yeah, it's not going to hurt you anyway. So what the hell?
Right. Yeah, it's amazing when you look at some of those baby formulas, because I've looked at those in the past, and they do have like an amazing profile of probiotics. The one big drag on that is, and it's actually infuriating, if you look at all the other junk that they put in those baby formulas, just, artificial sweeteners and artificial colors and, all these carcinogens. And
well, see, but if you go for those kind of formulas, for sure, I agree with you on that. But so this Gerber Soothe, it's a pure liquid formulation, so it's none of that. But the other part for people who want to try to clean diet, and especially if you go down the baby section, if you look at the chicken, beef, pork, it's just pure protein, pureed basically. Like if you need a nice clean source and a small snack portion control, okay, and you can mix a little lecithin with it and you're good to go. Like you got basically this pure little product and portion control. And so that's kind of, because sometimes one of the challenges with eating is, how do you make a small amount of something? And then you overeat because it's hard to manage your portion control. And so baby food actually, in the bottle, is sometimes nice to have around for just a quick protein snack. If you can, for pure energy. So
absolutely. I have a couple more selfish questions. How are we on time? I want to make sure
I'm good.
Because I'll go for hours with you, man. And I'm not exaggerating. I will go for hours with you. So please smack me when you've had
I got a call here in a few minutes, but they're part of the team here, so I can delay.
Yeah. And we could always do a part 2 as well, because there's so much here. And it's just, this is really, really rich information that I know there are going to be people driving going, what? Like they're in the car listening to the podcast. Yeah. What the heck? So here's a selfish one, because I'm looking at all of the potential insults to my brain in trying to get my brain back online. And one or two of my close friends who are holistic dentists have told me to start considering removing or addressing. I have 2 root canals that they were done by allopathic dentists. And unfortunately, they say that the canal can never be sufficiently cleaned, and it could be a never-ending generating bacterial nightmare that can travel to the brain and be one of the toxic insults on the brain. And I'm noticing I do get incredible brain fog after meals. So I don't know if that's a leaky gut situation, or if perhaps the food that I'm chewing is somehow traveling up that. And traditional medicine acknowledges the bacterial issues from the mouth to the brain. That's not
Yeah, that nerve, that's a direct one-way track. So yeah, so dental health is a big deal. Flossing regularly is really a big deal. And so yeah, so dental health is highly correlated with mental health, absolutely. And so that's something, and dentists know all about that stuff. And but yeah, the bacterial contamination from the gum to the brain is significant. So dental health is something people need to keep up on. Absolutely.
And this may be out of your purview, but would you recommend getting rid of the root canals and doing an implant?
Yeah, I don't know enough about that.
Okay.
I would refer you to experts in that field. So.
Yeah, I appreciate that. And that was, I am going to ask you selfish questions, but feel free to say, no, thank you. I'm not touching that one. Yeah. Okay. And well, all right. I am, one of the things I'm very excited about addressing is the leaky gut issue. And one of my other friends who is a compounding pharmacist, he's big in the peptide space. Mm-hmm. And he's saying very similar to things to you in terms of creating those tighter junctions, in the membranes. And it has to do with those different proteins you had mentioned working synergistically with some of the signaling peptides. Yeah. That you can, and the great thing about the signaling peptides is I can bypass my digestive tract with direct injections. Well,
there's the peptide field is growing, and there's some pretty amazing peptide work out there. I'm part of Dr. Seed's SSRP programming that I'm usually at his, Dr. William Seeds. He does a lot of the peptide. Well, he's an advanced, peptide practitioner. And so he has these seminars and sessions and educational programs. So there's a whole field of people out there.
Oh, great stuff so far. Just as a reminder, we're here with Dr. Dayan Goodenowe. He is a synthetic organic chemist. His PhD is in psychiatric medicine, looking at the biochemical mechanisms of psychiatric diseases and how the cellular systems of the brain interact with each other. He's also the founder, president, and CEO of Prodrome Sciences, which we'll talk about a little bit later, and the author of Breaking Alzheimer's, a 15-year crusade to expose the cause and, more importantly, deliver the cure. This book goes into critical detail about the biomarkers of dementia and Alzheimer's disease and the science and clinical applications of plasmalogens for the therapeutic treatment of Alzheimer's disease. We've had a great discussion so far. We've talked about the neurological intersections with plasmalogens, including MS, Alzheimer's, schizophrenia, autism, Parkinson's, and importantly for our audience, CTEs. We've talked about the acetylcholine deficiencies, trauma, genetics, and if people are suspecting that they have neurological cognitive issues and trying to heal their brain, or at least prevent further damage. We've talked about that as well, talked about the importance of a low carb diet, and not necessarily saying it's important. His answer to that was much more nuanced. Omega-9, plasmalogens, and so much more. Thank you so much for being here again with us, Doctor. I know there were some things you wanted to drill down on, some things I want to drill down some more on. But why don't you take the ball here? Because I know you had a nice present that you're going to wrap up in a nice bow around the ApoE4.
Yeah, well, thanks. I'm good to be back from our break there. So yeah, so we covered a lot of ground, a lot of detail. And so there's a couple of points that I wanted to kind of emphasize. One on the concussion part. I wanted to kind of this myelin bundle of axons, like your corpus callosum, like 200 million axons. When the myelin, when you get that shear stress that causes the concussion, when I was mentioning about rebuilding the myelin sheath, the protective coating, and I gave the analogy of the wire with the coating around it in your walls, which is accurate. But the myelin sheath is actually wrapped like electrician's tape around that wire. And so when you have inflammation and it's eating away at that coating, it eats away from the outside in. And so, but when you are growing the myelin, okay, the myelin sheath is building itself. So when I was explaining how if you can maintain the ability of those cells that keep your myelin sheath active, called your oligodendrocytes, if those oligodendrocytes can make plasmalogens and make myelin at the same rate or faster than the inflammation degradation, that's what prevents demyelination and prevents white matter disease. And so when you're talking about concussion prevention and being able to prepare the brain in advance of a potential concussion or head trauma, then that would be just the biochemical purpose of taking certain plasmalogens, proton glia and N-acetylcysteine and carnotine before a fight, basically, so that if you are getting pummeled, then you're actually, the building material to rebuild those membranes are present at the time of the insult. And obviously afterwards you want to restore that, but prevention is always stronger than restoration in all aspects of medicine. So that's one of the things that we want to work on in the future. Now, and the other one you mentioned was talking about the ApoE4 genotype. You were talking about amyloid a little bit. And I thought I could take a couple of minutes to kind of explain that whole concept, because people are worried about, hey, if I'm an ApoE4 carrier, my risk for Alzheimer's is increased. And what does that mean? And the amyloid plaques of Alzheimer's.
Should we be terrified, doctor? That's because it's a, like you were saying earlier, and they really don't, they sort of say, you don't, good luck with that. If you say, I want to get better from this, well, good luck with that. And they don't really seem to have in allopathic medicine, there's just doesn't seem to be too much recourse if you have the ApoE4.
Yeah, and so I've published extensively on that. So the ApoE genotype is completely, you can neutralize that genotype. And it's kind of like the analogy we're talking about regarding the ocean and the mountains under the ocean.
Who came up with that analogy? I'm just trying to remember.
Yeah, exactly. It was some guy named Jordan. Can't remember his last name. But so but for in terms of ApoE4, so the first thing, where you want to start with that is understanding what is ApoE4. ApoE4, so ApoE is an apolipoprotein. And that's what the body uses to transport cholesterol around the body. And it's like oil and water, right? You drop oil into your sink of water and it just bubbles up. You can't move it, stick to the pipes. And so how the body moves these fats around the body is it attaches it to highly polar proteins, molecules that are soluble in water. So they catch a ride on these proteins called apolipoproteins. And these proteins are what circulate in your blood supply, and they transport the cholesterol from your liver to all the cells of your body, and they catch a ride. So that's how you move these non-polar lipid oils through water. So they attach rides. So apolipoprotein E is one of those proteins. So the other ones people are familiar with is HDL. So when you look at your blood test for HDL, that's typically apolipoprotein A. Okay, that's ApoA is your HDL particles. And the other one is your LDL cholesterol, and that's ApoB. So these different lipoproteins have different letter designations to them, and they have different functions. So your LDL cholesterol that people all talk about, that's how you distribute cholesterol to all your cells from your liver. So that's your power supply to all the cells of the body of cholesterol. And then how cholesterol, and those LDL particles that contain the cholesterol, they actually go inside your cells. They come in the front door and they get goes into the kitchen and everything gets put in the pantry. Like it gets decomposed inside the cell. HDL particles they don't enter your cells. They stay on the outside of your cells and they do reverse cholesterol transport. And so you have extra cholesterol. This is like sending home extra turkey and pumpkin pie after Thanksgiving to your relatives. So they take this extra stuff and take it away. But they're not actually in the house. They're sitting outside in the car. And so HDL particles don't go into your cells. And so excess cholesterol in your cells gets sent out, and then HDL takes it back to your liver for recycling. And this is how you can balance how much you get into your cells and how much you send out. And that's cholesterol regulation. In the peripheral system, we use primarily these two proteins, HDL and LDL, which is ApoA and ApoB. And so apolipoprotein E is a unique one. It's ambidextrous. It can act both like LDL, it can enter your cells, and it can act exactly like HDL, which transports cholesterol outside of your cells. And what makes ApoE as a protein famous is that that's pretty well the only protein that your brain uses to transport cholesterol between the cells of the brain. And your brain is not like, your peripheral system is like an interstate highway system. You've got cholesterol generation in the liver, and it's transporting it all throughout your body, basically on big semi trucks driving down your veins and arteries. And your brain is more like Chinatown. It's a bunch of little streets, little side streets, no big thoroughfares. And so what it uses is ApoE, and it does ApoE for both, uses it for both functions. And so that's why ApoE is important. Now, there's three different genotypes about ApoE: E2, E3, and E4. And these are all what they call single nucleotide polymorphisms, SNPs. And the difference between the genotypes is very, very subtle. And so people with an ApoE4 genotype have an increased risk of Alzheimer's. And the reason they do is because ApoE4 is a cholesterol saver. So of all the genotypes, all the gobbledygook that you might hear about the ApoE genotype, it all comes down to really one protein in the brain and in the membrane that's related to cholesterol export. And it's a particular protein called ABCA1. But it's, and so ApoE4 carriers are cholesterol savers. They hold their cholesterol in their cells and they don't send as much out. And so classically, people with an ApoE4 genotype will have slightly higher levels of LDL because they don't need as much from the blood supply, so they don't take as much in from the blood supply. And ApoE3 is like the middle bear in Goldilocks. It has average levels. And ApoE2 can't hold on to its own cholesterol, so it's always spitting cholesterol out of the cells, which means that it's always pulling cholesterol in, which means they have lower levels of circulating LDL. Now, that's not a problem for most of the years of our life. In fact, the E4 genotype is actually protective early for against parasites and bacterial infections. It provides a more stable cellular environment. Now, fast forward to our 50s, 60s, and 70s, and the counterpart of this cholesterol export of the ApoE genotype is plasmalogens. Okay, there's another enzyme that does cholesterol esterification to clear the cholesterol to your membranes. And that protein requires high levels of plasmalogens in the membrane. So when we're young and we have high levels of plasmalogens, the ApoE4 genotype has no biological significance. But when we get older, when the plasmalogen levels in the membranes decrease, then all of a sudden that compensation mechanism for the ApoE4 genotype disappears. And the cholesterol in the membrane starts to increase because it's not being cleared properly or fast enough. And that increased level of cholesterol in the membrane is what causes the amyloid protein to accumulate in the brain. Okay, that's the biochemical mechanism. So amyloid comes from a protein called amyloid precursor protein, APP. Very critically important molecule. You cannot survive without it. Your neurons cannot grow without it. You cannot recover from injury without it. It is absolutely obligate to human life. And that precursor protein gets broken into one or two fragments. One is with alpha secretase, which is healthy, gives neurogenesis and all that stuff. The one is negative, is beta secretase, which provides the amyloid plaque. So what happens with people in ApoE4 carriers is that as they get older, they have a higher risk of getting amyloid accumulation in the brain because they don't clear cholesterol properly in the brain. Okay. And what's the negative consequence of that is not so much that the amyloid, so the amyloid is kind of amyloid is actually a biomarker of plasmalogen deficiency in the brain, ironically, because if you have high levels of plasmalogens in the brain, you have low levels of amyloid in the brain. So plasmalogens turn on the alpha secretase enzyme, the healthy clearing process. And about 95%, the vast majority of this precursor protein called APP is metabolized by this healthy protein called alpha secretase. And alpha secretase is under plasmalogen control. If you have high levels of plasmalogens, you have high levels of alpha secretase activity, and you have low levels of amyloid in the brain and high mental functionality. So people who have E4 genotype, but also have high plasmalogens, have no increased risk for Alzheimer's disease. So plasmalogen levels neutralize the genetic risk of the ApoE4 genotype. And that's been shown extensively. I've published a paper on 1,200 and some people in Chicago proving that point. And so simply, if you have an ApoE4 genotype, you want to make sure you have higher levels of plasmalogens because it neutralizes that genotype. So that's how it works. So amyloid itself is not
the enzyme that catalyzes the synthesis of the amyloid.
Correct. So you want to have, it's like a fork in the road, okay? And so you got APP coming down the road, and usually 95% of it go down the alpha secretase pathway, which is healthy and neurogenic for you. And about 5% goes down the beta secretase road. And when you have low plasmalogens, all of a sudden, instead of 95-5, it becomes 90-10, and then 85-15, and 80-20. And so as you get more going down the beta secretase pathway, you get amyloid accumulation in the brain. And so that's where the correlation between ApoE4 and Alzheimer's comes into play. So that's the story. I know it's a long story, but it's all about cholesterol regulation in the brain. And that's how plasmalogens neutralize the E4 genotype.
You know, it's funny. I'm sitting here listening to you, and sometimes I go in and out because it's intense, and on top of that, I have the brain fog issues. So, I was thinking of the irony that it's this very technology, if you will, this that you've discovered through the decades of hard work that you've put in to learn all this, but it's your ability to communicate it so effectively and so in such a clear way is due to the fact that you're actually doing this, right? You had mentioned earlier the fact that you're clearing your amyloid plaque on a regular basis. It's keeping you nice and crystal clear, so you can synthesize this and articulate it in such a clear fashion.
See, amyloid plaques.
So jealous of you.
Like even the original papers back in the 90s that, Brack did a bunch of, some of the main neuropathology of this was done in the 90s, early 90s. And they very clearly showed in postmortem brain tissue, areas where there was amyloid plaques, the neurological structure within those plaques was completely normal. Okay, we knew in the 80s, late 80s, early 90s, that amyloid itself was not neurotoxic to the neurons. Even the most sensitive parts of a neuron called the neurophil, those parts are completely intact in the presence of amyloid plaques. So we knew long time ago that amyloid plaques itself, they were not neurotoxic. Now you shouldn't have them. They're a good biomarker, but they're actually a biomarker of membrane dysfunction of the brain. That's what they're a biomarker of. Okay. And
because the brain is trying to sequester that toxic, it's sort of letting the damaged part go. It's sort of saying, okay, well, throw over the bad baggage. Like that baggage is corrupt and it's too heavy and it's leaking and the ship is going to sink if we don't get rid of it. Yeah, we won't have as much luggage, but we'll survive.
And that's the accumulation of the amyloid. Okay, so amyloid is sticky stuff, and the body will use it to basically, like fly paper, basically to sticky bad stuff will stick to it and accumulate. But the production and clearance of it, if you don't have those bacterial or spirochetes or spores that they need to be kind of sequestered with that fly paper, then it gets cleared out. So those are two separate things. So amyloid is a sticky thing. So it has a purpose of neutralizing or basically, sequestering, like you mentioned, nasty stuff. But you can also accumulate without that, and that's when you have the membrane dysfunction. So amyloid is a biomarker of reduced neurological function because your membranes are not working properly. Same thing with the neurofibrillary tangles. So the tangles are the second part of the Alzheimer's pathology. It's these little microtubule proteins that get all tangled up. And those are caused by your methyltransferase system, your homocysteine system not working properly. And so you can, again, B vitamins and other things actually are shown to prevent that neurofibrillary tangle formation. So I present that in more detail in my videos, but that's kind of how these biomarkers are important. But it's important to understand what the biomarkers are markers of. Like we think biomarkers are so proactive. It's like having a gas gauge on your car, okay, that shows E for empty. And you say, well, I don't like that. I'm just going to take my finger in there. I'm going to move it to full, put a piece of gum on it, and all of a sudden I get a full tank of gas. Well, no, it's just a gauge. It's just telling you what's going on in the gas tank. The gauge itself isn't driving your car. It's the gas in the gas tank. And so these biomarkers are exactly that. So if they're telling you what's going on in the gas tank, just changing the biomarker without changing the gas tank isn't going to give you any benefit. So that's why that's why removing amyloid plaque from the brain with antibodies or with drugs is basically just like that. It's just changing the gauge. It's not changing the gas in the tank.
And so it has counterproductive, right? Because if you take out the plaque and the tangles in the wrong way, doesn't it speed up the degradation of the brain? Because the brain is putting the plaque there to slow down the degradation. Right?
Yeah, like whenever you intervene in something like that, you have to balance the consequences. Like brain bleeds, like the brain bleeds are a big problem. That's been a historical.
Is that what
problem.
happens when you take out the plaque
Well, whether it's taking the plaque out itself or just the mechanism, like the drug itself, like once you start, pulling that stuff out of there, like you need to, if you're going to remove something, you got to fill it back in. Like you can't leave a void. And so that's, what are you replacing it with? And so that's where when you want to rebuild function, the function will push that out. Okay, it'll push the amyloid out and restore it with good neurological structure. So,
by the way, and sorry to interrupt, but this is so important to do that, to have that stuff kind of artificially pulled too quickly and not refill it in and get the brain bleeds and everything. It's my understanding that will cost you 20 to 50 grand per.
Yeah, it's
to do it the improper way.
Yeah, it's look, we live in a world where we've done this over and over and over again. We've developed drugs to move a biomarker, thinking that the biomarker is the disease causative agents. We've done this so many times, like Lorenzo's oil for X-linked leukodystrophy, the statins for cholesterol therapy. There's a whole host. Insulin versus dietary glucose control. You know, we have such a host of issues where we know just changing the biomarker without changing the cause of the biomarker has virtually no long-term clinical benefit. So, but we keep doing it. It's
if we could take a quick look at inflammation, because it's so important to the entire conversation. I was curious if you could tell me the intersection of plasmalogens with the macros. So, you know, I'm big on macros because I'm trying to, you know, increase my lean body mass to fat ratio while I'm trying to get my brain back. So I'm always, you know, kind of looking at my fats and my proteins and my carbs. But I understand that there is there's a danger in not doing the right types of proteins or the right types of fats, in that you could actually, based on inflammation, you could glycate your proteins, or you can oxidize your fats, and now your macros are now toxic and contributing to this conversation. Do plasmalogens address these issues of glycation and oxidation in any way?
well, oxidation for sure. So inflammation really isn't that complicated. Inflammation is your body, like I mentioned earlier, is a hybrid electric car. Okay, we physically burn carbohydrates into carbon dioxide and water, just the way your car engine does it. And so what we do ultimately is we release sunlight energy back to the universe, is what the human body does, is a collective issue. And it's about these electrons. Okay, so when people talk about redox or oxidative stress, these are catchphrases. But basically we're talking about electricity of the body. But the body isn't electrical like your wiring. Your body is biochemical. So what we have in the human body is called electrochemistry. And we move electrons around. So when people talk about the electron transport chain, or when you talk about CoQ10, these are molecules that capture electrons and move electrons around. And you can think of electrons like little hot potatoes, like so they go from one to another, and they just before they burn your fingers. And so what happens in your cells when it's oxidatively demanding for exercise and so on, your mitochondria are supposed to neutralize those electrons to water. That's what we take oxygen. We breathe oxygen. Oxygen gets converted to water in the body, and that's how the electrons from hydrocarbons go to oxygen into water. But when that gets overwhelmed, your cells, so all inflammation comes from oxidative stress, and ultimately comes from the intracellular part of the cell becomes overwhelmed, and it's electrochemical. And it says, I've got these electrons, and it's like electricity, right? Electricity is going to find a place, it's going to go. It's like static electricity, it'll give you a shock. So electricity inside your cells have to go someplace. And if it's overwhelmed and the cell can't convert those electrons into water, it starts spitting those electrons out of the cell. And then it spits it out of the cell, and then we have mechanisms. We have enzyme called superoxide dismutase that neutralizes the peroxide. Then we have catalase, and so on and so forth. So that's how your body spits these electrons out. If it can't spit, eventually these electrons will oxidize the membrane. And when the membrane gets oxidized, it creates a peroxide. Now this is when the outside world finally figures out something's wrong with the cell. And you can think of the cells of your body like your neighborhood, right? You don't really know what's going on in your neighbor's house, right? Until a chair comes flying out a window in the front lawn. Then all of a sudden you say, holy crap, something's going on over there, right? And then 911 gets called, and then the police come and they clean up the garbage, right? What's going on? So that's what happens to your cells. So all of a sudden it can't handle what's going on inside the cell, and it starts spitting these electrons out. And eventually the chair comes out the window and someone says, something's not healthy here. And then the immune system comes and is attracted to that. That's inflammation. Okay, now, depending on how bad the fire is, if, in the house, if it stays just to one house, then just one house gets burnt to the ground, the fire department cleans it up, and all the other houses are fine. Okay, we just have to repair one house. But if it's bad enough, the fire spreads to the whole neighborhood, and the whole neighborhood goes up in flames. And so that's inflammation. Okay, and so, which is why you basically go into a fire and say, holy crap, there's a fire going on. I'm going to take the water and I'm going to spray all the surrounding houses to make sure that they're water soaked so that the burning house doesn't spread to the non-burning houses. Plasmalogens are like that water. Okay, plasmalogens are basically like coating the surrounding houses with a protective coating so that that fire, that inflammation doesn't spread from the one cell that's burning out of control. And so that can get, and so plasmalogens are involved in that inflammatory cascade. And that's where all inflammation comes from that. All inflammation eventually can be traced back to failure for redox control of your cells. And then you have control mechanisms of it. So back to your macromolecule. So what happens is, if that oxidative redox capacity is impaired in a human being, they're CoQ10 deficient, they're iron deficient, they have other micronutrient deficiencies that are required for that, then you're going to get oxidized LDL. You're going to get glycated molecules, because once you get that oxidation state, then that oxidation state is going to get, your body's going to try to neutralize it. And one of the ways of neutralizing it is sticking a glucose molecule to it, like glycation and products. These are all downstream protective mechanisms that your body has. And so if you can correct the source of the problem, those multiple downstream effects don't occur, and it won't matter. And so, you still keep a good balance of diet, like your protein balances and so on and so forth. But if these core systems are working properly, these big systems can be managed fairly carefully. Like your lipid profile, that your lipids are important. Like we live in a world where we have a whole bunch of omega-6, corn, soy. Corn is in everything, right? Omega-6, and it's a critical fatty acid, but we have too much of it. And so you want to make sure you're balancing it with your omega-9 and your omega-3s. And so, because you're not going to get less omega-6 basically in your diet, because it's everywhere. So you just need to make sure you maintain that balance by getting extra omega-9 and omega-3 in your diet.
We've heard a lot about the omega-3, but the omega-9 seems to be a new thing. What are some good sources of omega-9s?
Olive oil is your main one.
Oh, okay.
And there's high oleic acid sunflower oils out there that they make. And so olive oil is a traditional source of omega-9. I think I got to double check them. Avocado, I think, has high omega-9.
Yeah, you get all that, like at a Whole Foods or, a Trader Joe's or even Sprouts or even Costco has avocado oil now. Obviously, the olive oil is easy, but the avocado oil, and that is.
And I don't quote me on the avocado. I can't remember. I don't have the in my head. So, but olive oil for sure. And then the omega-3s, mostly, your body doesn't use most plant-based omega-3s other than to make the final DHA, so the fish oil. But you can get algae oil now. You can get vegetarian sources. We use a vegetarian source. We have very high purity omega-3s in the Proton Neuro product. It's very highly bioavailable. And then we use sunflower as a source of our omega-9 for our glia products. So those are very, but in your dietary supply, the fatty fishes are always good to go for, the salmons and so on, for your long chain omega-3s.
Now, I know you have a real strong philosophy, doctor. I could tell, because the amount of discipline and the amount of persistence and dedication to have learned this to the degree that you have learned it, there's definitely something undergirding everything you're doing. And I've, as I've been studying your work, I noticed you kind of seem to have a philosophy on the science as well, where you generate the data first, and then based on that data, you're going to start looking at hypothesis, and you're going to start looking at testing. And can you tell us maybe, do a deeper dive into that philosophy, and also maybe, if you'd be so kind, like, what drives you? Why did you spend the last 3 decades? Really, I mean, this is a vertical, like, you're a vertical guy. Like, you've said, okay, I'm going to just dedicate my life to how does the body work, period.
Yeah, it's kind of a progression. And so, philosophically speaking, So the progression. So I started off as a young buck in pharmaceutical type of, developed this technology, use it for functional genomic medicine, try to, develop a bunch of diagnostic technologies for diagnosing different cancers. And so I use this biochemistry technology to understand how things work. Okay, first and foremost, because understanding at the basic level, we're biochemical. Okay, like philosophically, I look at the world in three big groups. You have biology, which is how organisms interact with each other, like our ecospheres, and even our social environments. And then you have chemistry, which is how molecules interact. And that's what we're basically chemical. We move electrons and we move atoms around. That's what makes the human body what it is. And then deeper, you get into physics, right? You get into quantum mechanics, the basic nature of reality. But biochemistry is really what drives our living world, and trying to understand that. And then as you learn, it's important to continually unlearn. One of our biggest problems isn't the acquiring of knowledge, it's we forget to maintain our ignorance and our naivete. Because biases, like as soon as you become an expert, you can't learn anything. And so you have to humble yourself to a point that, despite the amount of knowledge that we know, the knowledge that we don't know dwarfs it, right? And so we need to be humble about that concept and look at the empirical evidence. And when you're younger, you think you can solve all these problems, right? You think you're smart enough to work your way through all this stuff. And eventually you realize, you're just not that smart. It's just, there's no, and so you have to kind of step back and say, let's look at the empirical evidence. Let's see where the evidence takes us. And we learn more and more from it. But we build biases up, and we have learned behaviors. And that's very protective as we get older, right? Because we don't do all the dumb stuff that we did when we were young. And that's a good thing for a certain degree. But it also prevents us from other risk-taking behaviors, which actually have a smaller probability of success, but they have the bigger reward if they're successful at it. And so we protect ourselves to death as we get older because we're so damn smart. We're too smart to make mistakes. And so you have to kind of unlearn your expertise as you go forward and be prepared that the best hypothesis that you could think of, beautiful theory, could be wrong, okay? And you have to accept that and build from it one step at a time and understand the functional endpoints of what we're doing. And so I started off, with pharmaceuticals, developing synthesis, and I got some patents on drugs and diagnostics and technology and hardware and software and a whole bunch of stuff that I've developed over the years. And over time, it starts to get to this point where you're saying, what am I doing this for? We have so much knowledge. We're not implementing any of it. And so that's really what changed my life several years ago, saying, I got to get out of this glass ivory tower looking at humans in large numbers and how to diagnose this disease and that disease, and start figuring out how we can help people. And how do we actually start implementing some of this knowledge, like on several levels, the cancer level, the Alzheimer's level, autism level, multiple sclerosis, even bipolar, schizophrenia, depression systems. Like these are diagnosable, intervenable disease states. And so it's not from a lack of knowledge, it's a lack of ability to implement it. So there's a logistical issue of helping people, okay? And getting away from the egotistical thing, how smart am I? I can diagnose this and I can develop this technology. But are you actually helping anybody? Are you actually, and so I think that's the hardest part of, when we talk about longevity and immortality, part of that is teaching ourselves to continue to be a little bit stupid. Like you have to actually, because if you become too much of an expert in anything, you're blocked. You can't think. You can't. You eliminate options before you fully evaluated their outcomes. And then you become personally vested in these theories, or these belief systems become no longer scientific, but personal. And that's really the kiss of death in science, because it's more about maintaining a certain status or a certain reputation. And so if a given hypothesis fails, the scientist feels that they have failed personally because it failed. When in fact, that's what science is all about, is presenting the best hypothesis at the time until the next guy can knock it down. And you have, if we don't do that, we don't move forward. But the problem is, we live in a real world of humans, and humans have mortgages and payments and bills, and you can't all of a sudden spend 2 decades on amyloid hypothesis and say, this is dumb, and you put basically $2 trillion worth of people out of work. And so these momentums and these inertias move slowly when you deal with real humans. So that's kind of where my passion comes in, is saying, it starts with one person. Let's help what we can. Let's develop infrastructure. Let's develop mechanisms of delivery, and let's maintain this empirical proof in the pudding type. It has to work. People have to. We've been suckered into thinking that nothing ever works. Like, we've been suckered into thinking that health is, just accept less than optimal. And so we don't even accept it. The elderly population it's just accept your own death. And I just don't understand. We got to break that down. So that's, I know I'm babbling, but that's kind of where you kind of have to start really thinking at these basic pillars of thought. And if you're going to be sincere about changing some of this stuff, you have to be sincere about your own history and trying to get some of this stuff done, and kind of look at the world as it really is. So that's so exciting about being at Prodrome and with the drgoodenowe.com site, is that we're implementing protocols in everyday people's lives and finding ways of solutions. These supplement industries we're talking about, like these supplement protocols, these biochemical optimization protocols. Well, these, like, you can't, how do you monetize N-acetylcysteine? Okay, like it's ridiculously cheap. Like, there's no way, like, no one can run a $20 million clinical trial on a molecule that you can buy from 6 different providers for pennies a pill. Like, you just, no one's going to do it, right? And so now you get a bunch of these little marketing trials done here and there, and there's no mechanism to deliver this type of medicine. So the biggest challenge for me has been to, how do you develop a sustainable infrastructure that can grow? And that's what we do with our protocols and our blood testing and supplements and these outcome analysis. So people can actually, in a cost-effective way, in a managed way, get real results in their lives. So those are the things that kind of I focus my energy on now. It's on the implementation side of things, and then try to figure out what order you do it, because you can't. It's a pretty big fire hose, like this conversation we're having right now, right? Like, this is still lucky to be 1% of, like, the mass spectrometry data. I've probably measured 500,000 molecules in humans. Okay, like the data is very large, but the core components of delivery is a triage. Like, where do you want to start? And so that's why I focused on these big issues, like your membrane structure, mitochondrial function, inflammation. If you can solve most of those things, you're 90% of the way into optimal health.
Yeah, it's interesting, talking about the expense of running these studies. And I was realizing, boy, it's kind of when you look at how, it's in the millions, it's actually a very, I get the importance of doing it. I get the need of doing it, improving. I'm completely behind double blind and peer reviewed and replicable. That all is, that's science. Obviously, it's like, that's one of the most beautiful thing that mankind has invented. I get the importance of it, but I also get the restrictive nature of it. And it's a way of keeping people who have altruistic intentions like you, and who are insanely smart, and you have such brilliance to bring to the field, the costs are a very effective way to keep people like you off the field.
Yeah.
To keep you from playing, right? Because it's cost prohibitive, and so, it's kind of one of those. I get the importance and the need to do it, but it's also a little bit tricky. It's a way of keeping the big boys on the field.
Oh, totally is. And but like you take the good with the bad. Like there is the new trial design formats, like the adaptive trial designs. There's ways we can do this scientifically, creating critical mass. We'll be building, like we'll start a forever trial in the coming year, basically never-ending clinical trials where we look at multiple endpoints that we're talking about. We have solutions that are population-wide solutions. You need to hit the numbers, but there's ways of doing this in a different way. And the biggest way is to getting out of the patented pharmaceutical trap and the FDA trap. I've had good relationships with the FDA over the years, and I've never had there's other than some weird stuff this last few years, but for the most part, they're decent scientists, and they have a purpose: one drug, one indication. Okay, and there are ways of determining whether that works or not. You can't fault the system for that. If we create more and more diseases, that we create micro drugs for micro diseases, then the system is going to be designed around that. I remember a story. I was in the Dutch West Indies. I don't know how many years ago, but there was I can't even remember the city. So, but it was a weird this street, right? And it's all these houses with really, really narrow store fronts, right? Like the houses would have basically just a front door on the street, and then they would balloon outward from the front door. And the reason the houses were built that way is because houses were not taxed based upon their square footage. They were taxed based on the linear foot size of their house at the street corner. So everyone says, well, if I'm going to get taxed on how big the front door of my house is, I'm going to have a small front door, and I'm going to have this huge house behind it. And so all I'm being taxed on is a 12-foot linear foot. And so people will, but it's an example of how we will modify to within the parameters that are set for us.
Yes.
And so if we set the taxation at this, I'm going to build houses that way. Yep. So if we set the FDA and here's how we validate a drug, then everyone's going to do it that way, because that's the most cost. That if you want to get a drug, if this is the rules to get play, then you'll play that. So you can't really fault the pharmaceutical companies, other than the fact that they manipulate to try to get those rules, but not all. Like most of them are just doing what they can. Our job is to break out of that mold. And one of the ways we break out of that mold is saying, why are we playing this game at all?
Yep.
Like what there's no point in this. And so that's what we do differently.
You discovered something when you had that fundamental shift, when you got out, as you said, out of the ivory tower. And, for a while, it seems that it was a money-making thing for you with the patents and with the, you had kind of fallen into that model, and you were looking for happiness within that model. We're all looking for happiness all the time. And the big irony is, it's not until we stop resisting our nature, right? Like our nature is we're tribal. Like we want to all be together. We all want to help each other. We all want to help the tribe. Like that's how Homo sapiens got to where it got, was by being in the tribe. Because if you're not in the tribe, you're toast. And so being in the tribe feels really good, and helping everyone in the tribe feels really good. And that's where I think if we're looking at a macro view of what you're talking about, where we've dropped the ball. Like we think that if we can just make enough money, it's kind of an old story. I know I'm beating a dead horse here, but we think if we just make enough money, we'll finally be happy. And in reality, it's like, so I was saying, when I got the 500 downloads on my last podcast that I did about 3 weeks ago, I was so freaking excited. I got 14 million views on my Gina Carano fight. 14 million views. And I'm kind of like, oh, that's cool. That's kind of like, it was nice. That's a nice number to look at. But the 500 warmed me. It made me feel like there's some people in there who grab something and it could save someone's mother. It could save someone's daughter. It could save, like, that feels really good. That feels good. Like, I can't quantify that. That's humanity. It's not quantifiable. And so it's that transition from greed is what we're talking about. The pharmaceutical model, like you say, they're all good people. The people who are running Pfizer, the people who are running, Monsanto, the people who we want to vilify, they all had Christmas.
Yeah,
they were all buying presents for their kids, just like we are.
You're in a system, and it's like, our humans, everything is balanced. It's a bell curve. Everything that's good has an equal bad. Okay. I tell people the source of our joy and the source of our pain is the same thing. Human empathy. Okay. We have the ability to feel others. We feel their pain. We want to, but our ability to feel someone's pain also gives us the ability to inflict it. Okay. So it's equal. Okay. So our ability to do good is equally balanced with our ability to do bad. And we talk about groups of people that can form together to do good things. Well, groups of people can form together to do bad things as well. And so our ability to create groups, to build the Hoover Dam, or to do the things that we say are great, that allows humans to coalesce into one common motive. Okay, that ability for us to combine our forces to do good, if manipulated, can be combined to do bad. The greatest atrocities that have occurred on this planet have occurred not by one person. It's by a group of people being able to group people into a mindset that, they get brainwashed into it. But that's how, but that ability of us to work as a team, okay, in the sports, where we can cheer for one team versus another, okay, and really get into it. That's the source of our power, but that power can be used for good and evil. And the biggest challenge is to get the tent as big as possible. So the more people that are in your family and that you associate with, and the bigger your family becomes, the less likely you are to damage or harm that family. And so the biggest thing for us is to eliminate some of these differences, because the differences are exaggerated amongst us, but they allow us to objectify one group versus another and create one group as lesser than another. And that's but that's part of the negative side of being human. And so the biggest thing for us is the larger the tent, the bigger the family, okay, the less likely that you're going to have, you're always going to have issues, always, but the less likely you're going to have this, the dehumanization of others. And so what we're doing here in terms of with plasmalogens and with prodrome and with dietary supplements and protocols is to build that larger and larger and larger family of people that are interested in health, that are interested in practical, objective measurements. And there's a big group of people out there that are really hungry for this. And it's growing. And it takes a while for people to learn that there isn't a drug for everything. And basically what human biochemistry is all about. We can fix a lot of stuff just with biochemical engineering. So that's kind of philosophically. And so our challenge is, when you have something that works, is how do you distribute it? How do you build people into it? And at the end, it's just like you said, you get your 500 downloads, you help one person at a time, and one person becomes 2 people, and 2 people become 4 people, and 4 people become 8 people. And that's
a tribe. You get people like me who I can tell based on researching you and looking into you and seeing, and now with this extensive conversation, I can see what your motives are, your intentions, and I can see you've gone, like you said, you've gone over that bell curve and you've gotten to the other side of, oh, there's a lot more joy on the side of helping and thinking altruistically and thinking, in a plurality type of way. You referenced this one. I had to go check it out because when you had referenced fixed mindset, versus an open mindset. There's a wonderful book by a woman named Dr. Carol Dweck. She's out of Stanford. Are you familiar with it?
No, I'm not.
It looked like it when the way you had said yes. She wrote the definitive book on fixed mindsets versus open mindsets. She's an absolute killer. It's DWECK, I believe. But just as a couple of quick ones. So here's your fixed mindset. Believe intelligence and talent are static. Avoid challenges to avoid failure, which you were referencing. Ignore feedback from others. Feel threatened by the success of others. Hide flaws so as not to be judged by others. Believe putting in effort is worthless. View feedback as criticism. Give up easily. Now, here's all of the antecedents to those. Embrace lifelong learning. Believe intelligence can be improved. Put in more effort to learn. Believe effort leads to mastery. Believe failures are just temporary setbacks. View feedback as a source of information. You were talking about that, the source, that the disease is your biomarker, your source of information. Willingly embrace challenge. View others' success as a source of inspiration, and view feedback as an opportunity to learn. So it's I can't remember the name. What is the name of her book? This is just a quick little thing on growth versus fixed. I don't even know if it's on Carol's book, but anyway, it's Carol Dweck. To reference that, it's a wonderful, wonderful read. Hey man, I've been so greedy with your time, and I know we've gone into the philosophical bent.
No worries.
And but I think the most important thing to as we recap everything, is your philosophy on the prevention of disease, keeping Tom Brady on the field. The prevention of disease is so different than the treatment of disease. And if we can just realize the metaphors that we've touched upon in this show, that is the game changer.
Correct. See, the maintenance of function is the prevention of disease. The maintenance of function is longevity. Okay. And collectively, the maintenance of all function is immortality. So really, if you can maintain function at its core, there is no place for disease to exist. Disease only appears when function declines. And so it's a very simple, so it's prevention, but it's not prevention in terms of setting up walls. It's prevention in basically maintaining function. And so if you maintain function, you can't actually have disease. So, so it's prevention, but it's prevention through maintaining optimal function.
You named the company Prodrome Sciences. That's Prodrome. What does prodrome mean?
Prodrome is that which comes before. It's basically predictability. So the prodrome of dementia is low plasmalogens. Okay, so it occurs prior to the event. So prodromes are the precursor or the earliest indications of a future event. And so originally we're looking at prodromes of disease, but you also have, those are prodromes of negative outcomes, but you also have prodromes of positive outcomes. So you can have prodromes of advanced health and prodromes of advanced longevity as well. So prodrome doesn't have a value to a prodrome of a negative or a prodrome of a positive. It is just the ability to predict the future. It is what occurs prior to the next step.
Doctor, are there any stories before we wrap that particularly stand out in your mind that made you say, oh, hell, I know I left the big money of patents and the ivory tower, and I left, standard traditional allopathic pharmaceutical medicine. And this one alone made the whole damn thing worth it.
Well, it's all made it worth it.
Yeah.
But really what it was is that I wish I could take credit for being smarter than I am, but I really got my head beat against the wall enough times in different disease states to finally realize, okay, this is not going to work. So eventually I came to conclusion, like the plasmalogen precursors, I invented these in 2006 or 7, for crying out loud. And so we were preventing neurodegeneration in diseases years and years ago. The diagnostic accuracy, I've done 6,000 person clinical trials for colon cancer, pancreas. I probably did 20, 30,000 people in cancer screening technology. Like, so I've done huge studies, presented them at governmental levels saying, hey, here, simple blood test. We can have an 86% detection rate of stage 0 colon cancer. We can predict which polyp positive people will go on to cancer. And then to realize that the government's just, none of this stuff gets picked up. Like we have our cancer tests and our colon and pancreatic screening tests sold in Japan, but it's at some point you realize, you know what? It's not going to work in the current system. The current system is just not designed for preventative medicine. It's not designed for this. And so basically we have to recreate the system. At some point you come and say, you know what, no amount of beating my head against the wall is going to change this because it's fundamentally not how they work. It's like saying, okay, you really can't take Macy's and turn it into Amazon. Okay, like they're just different platforms, they're different constructs. They don't, and they have their own historical legacy issues, and they're built layer upon layer upon layer upon layer. Like it's people, and I think the average person doesn't really understand how illogical it is to us, but how logical it is at the government level. So for instance, colon cancer screening. So you would think, oh, wow, if I can spend $100 million, or if I can spend $10 million with increased screening, and I can save $100 million in pharmaceutical and hospitalization costs, and an average person will look at that and say, wow, 100,000, 10, that's a $90 million savings. Okay, but that's average person math. Government math, that's not government math. Government math is not that I saved, is that now it cost me $110 million. So I was currently spending $100 million. And so when the governmental math is not an extra 10 doesn't save me 90, because that 90 million is going to get spent somewhere else. So that extra 10 just gets added on. So in governmental math, that's not a $90 million saving. It's just a $10 million cost. And so there's an extra, so now so the average Joe looks at this and says, wow, it's awesome. Why wouldn't someone do this? Because I'm going to save $90 million. Well, that's in budget B. Budget A is over here. So if I increase budget A by $10 million, I've just spent $10 million more.
Well, if the CDC doesn't spend that 90 million, they're not going to get it in their next budget. Right. The next quarter, they won't get it from Congress.
So that kind of cost saving doesn't compute.
They need to spend the 90 because they won't get the 90 the next time.
And so the average person says, well, why wouldn't you do that? Because governments, that's not how their money gets spent and how it gets allocated and how it gets. And so people look at this stuff and say, this doesn't make any sense. This is just stupid. Yeah. And reality is, it is stupid, but it is what it is. And so you're not going to change it. So the best way. So rather than if you take Amazon versus Macy's, you can't turn Macy's into Amazon, but Amazon can start in a garage and become Amazon. Okay. And so you have to build that infrastructure. You have to create that platform and build that out. So the current system that we're dealing with right now is you can't expect it to change its structure. Okay. There's too much inertia baked into it. And so the only way to do the things that we're doing is you have to build it from the bottom up. and then build it with that knowledge base that it's going to have to gradually spread out that way. And I think too many people want to work within, like if I'm a clothing designer, I'm selling in Macy's. And so you don't even have a, like so most people can't build the entire infrastructure.
Right.
They can only build one piece of the puzzle. So if I'm just going to make one supplement, okay, I can't develop an entire distribution channel just for this XYZ, supplement. I'm stuck selling it through Amazon, selling it through whatever structure is out there, right? But if you have a big enough platform, then you say, well, no, you know what? We can create an entire infrastructure over the course of time. And that's kind of what we're doing.
Do you have a wish list based upon that information that you are hoping to accomplish, that people might be able to contribute to in some way? Any kind of meetup groups or any kind of outreach to governmental entities, any pet projects that you're hoping to either get going or to...
Oh, we got lots. Like our Alzheimer's program, our dementia trials. We'll start several large clinical trials in this coming year, and we'll be reaching out to different user groups, and we're continuing to grow out our infrastructure and platform. Yeah, so no, there's lots and lots of outreach going on. And so that's what we'll continue to build upon, both here in the United States and in other countries. And so we'll, there's no really, it's an incremental build out. That's all.
One project that really comes to me, Doctor, and there's about 10 that you and I can work on together, but one that just is like low hanging fruit is protecting my fighters before they go into the cage. We could get a lot of support for that right off the bat from state regulatory, anything that protects the fighters in any way. The state regulatory agencies and governmental entities will probably get behind. So
we could easily just run a small clinical trial showing the before and after. The advanced MRI technologies now, we can measure this inflammation in real time, and we can very quickly show how the benefit is. And that's what we're dealing with, more advanced MRI, and then you can roll it out from there. But absolutely, that's what I would do, is just show before and after and saying, here's the difference.
Yes. And I can get some media behind that as well.
Yeah, so you can get the MRI imagery, but you can also get just the individuals, their own personal outcomes. They'll know the difference. And so
right. That's another bit of low hanging fruit for me. I will be doing this, and I will be, I need to have the visuals, whatever they are, PET scans or the blood panels, whatever will show the difference. Cause the anecdotal is what moves me.
Yeah.
And that was definitely another last piece before we go that I wanted, if there was any personal stories of people who've reached out to you based on your precursors and your prodrome and said,
oh yeah, I got hundreds of stories of
can people access those stories like on your website?
No, we're going to get to that.
Videos live anywhere?
Not yet. This coming year, we'll start sharing all this anecdotal work, and we'll start, and we can work together on some of that stuff. But yeah, that's one of my priorities for the coming year. We've just had a lot of rapid growth, and we've had a lot of feedback and growth in our doctor networks. So we have well over 500 doctors using our products. And that's just here in the United States. So
that's another bit of synergy for us, because I'm pretty plugged in with a lot of doctors.
Yeah. And then that just tells you it's working, right? Yep. I got these doctors, their patients are getting better. And that's we'll go from there. And so
yeah, it's a closed circuit. It feeds itself, because you can see, as you and I start discussing, you see the last 3 subjects lit us up.
Yeah,
the last 3 subjects lit us up, because it's what drives us.
Exactly. It's and you got to be committed to the long haul on this thing. Like, you can't say you're in pursuit of functional immortality or longevity and have a 5-year plan. No, you need a 50-year, 100-year plan. Okay, you plan forever, right? It's a
Right.
forever plan. And
Open mindset. Yep.
right. And so you can't, like, you have to look at it that way. And so when you look at building, I always tell people, plan like you're immortal, but live each day like it's your last, right? You're immortal, right? Because
That's stoic. You got some
right?
Marcus Aurelius going there, man.
Right.
That's
Well, basically,
stoicism.
because otherwise, like, you don't want to be apathetic. Say, oh, manana, I can do it tomorrow. No, so live each day to get as much out of each day as you possibly can, but plan like you're living forever. So set your stories, set your plans up, set your strategy for an infinite lifespan, and then live each day to achieve that, but live each day like it's going to be your last. And, make sure your loose ends are done as much as you can. And then you go to sleep at night.
His PhD is in psychiatric medicine, looking at the biochemical mechanisms of psychiatric diseases and how the cellular systems of the brain interact with each other. He's the founder, president, and CEO of Prodrome Sciences. That's Prodrome, and the author of Breaking Alzheimer's, a 15-year crusade to expose the cause and deliver the cure. The book goes into critical detail about the biomarkers of dementia and Alzheimer's disease and the science and clinical applications of plasmalogens for the therapeutic treatment of Alzheimer's disease. And even more importantly than all of that, he's an awesome guy.
Thanks, Jordan.
Thank you so much, Dave.
Rest of your day.
And I just one more time, I want to thank you for all of us who this is life or death information. So that's something, please keep in mind every time you're going through your day. You're changing worlds, doctor.
Well, thank you so much. I really appreciate it.
Talk soon, and I'll circle back with you.
You got it.
Cheers.
For our full schedule of fights on the NBC Sports Network, CW and ABC affiliates, visit UnitedFightAlliance.com. Listen to us on Apple Podcasts, Google Podcasts, Podbean, Spotify and Amazon Music. United Fight Alliance, for the fighter in you.